Good evening. We'll wait for 2 more minutes. Let us start our discussion. Yesterday, our discussion went on convolution property as well as Parseval's theorem, and the last one, Plancherol's relation. Convolution in one domain corresponds to multiplication in other domain. There we checked when we try to convolve SAF function with itself or sinc function with itself. Again, the resultant signal is SAF function or sinc function only. Similarly, Gaussian convolved by Gaussian function also we observed as Gaussian function. With respect to properties, there are certain differences between omega form and F form with respect to properties. Let me give that clarification. With respect to properties, there are certain differences between omega form and F form. So where the difference comes, let me discuss. Property, how we have chosen an omega form, what is the equivalent modification in F notation. One property we are making the difference is a duality. Capital X of t means omega form we have written 2 pi into small x of minus omega. In F symbol it is simply small x of minus f. There is no 2 pi tag. One more property, multiplication in time domain. If you say x1t multiplied by x2t, it is 1 over 2 pi x1 omega convolved x2 omega, but F form it is x1f convolved x2f. Again, no 1 by. Next, the Parseval's theorem, sir. What is Parseval's theorem? Integral mod xt square dt. In omega domain, we have 1 over 2 pi integral mod x omega whole square d omega. F symbol, there is no 1 by 2 pi tag. Last one, the Plancherol's case, integral xt yt dt means, of course, the signal, one of the signal may be complex. 1 over 2 pi integral x omega y conjugate omega d omega. Here, integral x of f y conjugate f df. When you see, only these properties have the 2 pi or 1 by 2 pi tag, sir. Only these properties are having 2 pi or 1 by 2 pi tag. How much time still the classes are left? One fellow is asking. Still I have to discuss 4 more topics: Laplace, DTFT, jet transform, filter design, exclusive for instrumentation, the newly added topic, discrete time processing of continuous signals. Don't be tense here. Till 23rd, I planned, as per the schedule, till 23rd, maybe approximately another 25 to 30 hours is left. So concentrate on what I am discussing. Leave the other things. Okay. Why only these properties have the 2 pi or 1 by 2 pi tag means because their proofs are based on inverse Fourier definition. What is inverse Fourier definition? We know with respect to omega. Just recollect everyone, sir. 1 over 2 pi integral x omega e power j omega t d omega. But how we have written the same in f symbol forms are integral x of f e power j2 pi ft df. D omega by 2 pi is df or not? D omega 2 pi is df. Okay. So don't have unnecessary confusion between omega form and f form. In omega form, 2 pi or 1 by 2 pi extra tag is there means in f form, skip that multiplier. No need to take that extra multiplier. Because we know already wherever omega is there, generally it is replaced as 2 pi f. That is one modification. Another modification is what? 2 pi del omega is equivalent to del f. 2 pi del omega is equivalent to del f. These two are the modifications in the standard formula, sir. So with respect to properties, how to convert omega symbol to f symbol means wherever the 2 pi or 1 by 2 pi scaling factor is there in omega form, no need to take them in f notation. Why only these properties have that extra scaling factor means for proving the properties, we are using our inverse Fourier definition. Inverse Fourier transform contains this tag. 1 by 2 pi is there or not, sir? Okay. Rest of the properties, no modification. We know d by dt means j omega. Instead of j omega, what we are writing? j2 pi f. Yesterday also we have done. Correct or not? D by dt is j omega. J omega plus j2 pi f. J omega plus j2 pi f. Similarly, d by d omega means minus jt. D by d omega means minus jt. That we have written as d by df is minus j2 pi. Only these 4 properties when you have 2 pi or 1 by 2 pi scaling factor in omega form. Try to skip them in f form. In f form, there is no 1 by 2 pi. Correct or not? Inverse Fourier definition I am saying. Inverse Fourier definition. And one more doubt. Most of the fellows have expressed it. Let me discuss that also. If we are taking a symmetrical rectangle from -1 to 1, everyone tell me what is the standard Fourier transform answer we are writing, sir? If you take a rectangle from -1 to 1, what is the area under this? 2. SA of omega into positive width of the rectangle is 1 or not? Area to SA of. How to write the same answer in F form means 2 sinc omega by pi just divided by pi. Because we studied sinc x as what? SA of pi x. Sinc x we studied as SA of pi x. Correct or not? So SA of omega, how to convert to sinc form means sinc omega by pi. Everyone tell me how to write the same answer in F form. Omega place 2 pi f or not? Directly omega place 2 pi f means 2 sinc of 2 pi f by pi, that is 2 sinc 2f. 2 sinc. So this conversion also some fellows have doubt. This conversion also. When you take a symmetrical rectangle, first area to SA of omega into positive width. Sinc x is SA of pi x. So pi x is lambda means it becomes omega by pi. Omega plus 2 pi f means it becomes 2 sinc 2f. Okay, 2 sinc 2f. Good. So along with me, one more co-host is there. He is looking after all your questions. I will concentrate on the class today. Okay. Along with me, one more member is there as co-host. He is looking after all your questions regarding the material, all other things. I will look after only our discussion, sir, subject discussion. Okay. Still, if you have any problems, we'll see in the ending. Okay. Okay. Today, we are going to discuss applications of Fourier transform topic. Today, we are going to discuss certain applications of Fourier transform. What applications we are discussing is, first we are starting with the distortionless transmission. What is the condition to avoid distortion? What is the condition to avoid distortionless transmission? Where we are learning phase and group delay concepts there. Second application is Hilbert transform, 90 degrees phase shifter. Hilbert transform. We observed brief introduction about Hilbert transform under duality. 1 by pi t is taken as Hilbert transform. Third application we are discussing is correlation. Autocorrelation and cross correlation concepts with properties. Autocorrelation and cross correlation. Last application of the topic is sampling theorem. First we have to discuss sampling theorem for band limited signals. Then we are going for band pass signals also. Band limited signals, band pass signals also. Okay. These are the applications to be discussed. This will take approximately 6 to 7 hours discussion. Listen carefully. So generally, their favorite and regular topic in competitive exams is this last two: autocorrelation, cross correlation, sampling theorem. Depending on the mood, they may touch these two topics also. In our syllabus, phase and group delay are separately mentioned. Phase delay, group delay. We are discussing today, even in discrete system also, DTFT also. Again, I will repeat you. First, now we are discussing for analog form, sir, under distortionless transmission. Okay. So these are the different applications we have to study. Applications of Fourier transform. Let us start with distortionless transmission. What is the meaning of this word? Distortion is waveform perturbation. If the original shape of the signal is changed, then we can say distortion has occurred. Waveform perturbation. If the shape of the signal is changed, then we can say some form of distortion has. So whatever the system we are designing, we can say it is distortionless if the input and output graphs are looking like same. If the input and output graphs are looking like same, the considered system is distortionless system, sir. What does it mean? If the input signal is xt, output must be same as the original signal. There may be amplitude scaling, there may be certain amount of delay also. output may be scaled and shifted version of the original input. Whenever the input and output graphs are looking like same, whenever the input and output graphs are looking like same, then we can say the considered system is distortionless system. Distortion meaning is waveform perturbation. Whenever the shape of the signal is changed, then we can say distortion has occurred. There is difference between the words distortion, noise. Noise is a random signal which is coming from external sources. Noise is a random signal that is coming from external sources. Distortion is a deterministic signal that is caused due to internal components of the system. Distortion is due to internal components of the system. Whether we are getting amplitude distortion or phase distortion, that we will know, sir. Noise you cannot predict. When you are crossing the traffic junction, there will be a man-made noise. We are waiting until we get the signal. So many fellows are in hurry, continuously horning or not. That is man-made noise. You cannot feel that like A.R. Rahman music, classical music. Right or not? So noise is a random signal which we cannot predict its behavior. So there are two differences between the word distortion and noise. Distortion is due to internal components of the system. Distortion is due to internal components of the system. Noise is coming from external sources. Distortion is deterministic signal, noise is random signal. So in the time domain, what we can say is the considered system is distortionless system whenever the input and output graphs are one and it means when we try to apply this as input signal, when you are trying to apply this as input signal, sir, at the output side, if we have detected the same graph with certain amount of delay as well as there is change in amplitude, no problem. Instead of plus or minus 1, amplitude changes to plus or minus half, sir. There is certain amount of delay. So a system is distortionless if the input and output are one and same, exact replica. But if you got the same waveform in a zigzag manner like this, we can say some form of distortion has occurred. Okay. So what is distortionless transmission condition? Output is exact replica of the input. Exact replica of the input with scaling in its amplitude. With scaling in its amplitude and a possible delay. And possible, there may be change in its amplitude level as well as there may be certain amount of delay. But as most of our practical systems we are taking our filters, any filter means frequency response comes into picture, sir. Any filter means frequency response comes into. Tell me what is the Fourier transform for this expression, sir? Time shifting property or not? Y omega equals to k e power minus j omega t naught into x of omega. K e power minus j omega t naught into x of, from which the frequency response of the system is, if you want to get the frequency response of the system, it is Fourier transform of output by Fourier transform of input. The answer is simply k e power minus j omega t naught. The answer is simply k e power minus j omega, which is looking like a polar quantity that will have certain magnitude as well as phase angle, which is looking like a polar quantity r e power j theta style that is having certain magnitude as well as. What is the magnitude of this term, sir? Mod h omega equals to what? Modulus of k. It means magnitude spectrum is constant for all frequencies. Magnitude spectrum is constant for all frequencies. In e power j theta, what is the phase angle, sir? In e power j theta, what is the phase angle? Minus omega. Phase spectrum is a straight line passing through origin with negative slope. Phase spectrum is a straight line passing through origin with negative slope. This is the equivalent condition we have to satisfy. In frequency domain, magnitude spectrum must be constant, phase spectrum must be linear function of frequency. If the magnitude is not constant, if the magnitude is not constant, then we can say it is magnitude or phase distortion. If phase is not a straight line, sir, then it is called as phase or delay distortion. Distortion also we have two forms, sir. Linear distortion, non-linear distortion. In signal subject, we are dealing linear distortion because our systems are LTA, systems are not. Our systems are non-linear distortion. You are learning in communication subject, quantization error. That is a non-linear form of distortion, quantization error. Whenever the magnitude is not constant, it is called as magnitude distortion. Phase is not a straight line, that is called as phase or delay distortion. Both are combinedly called as linear form of distortion. So everyone tell me difference in the word distortion and noise. Distortion is due to internal components of the system. Noise is coming from external sources. Distortion is due to internal components of the system. Noise is coming from external sources. Another difference is distortion is deterministic. Our system will create what type of noise, what type of distortion we will know. But noise is a random signal. So time domain, what is the condition, sir? Time domain, what is the condition? Whenever output is same as input with scaling in its amplitude and certain amount of delay, that is distortionless. What is the same condition in frequency domain, sir? What is the same condition in frequency domain? Magnitude spectrum must be constant. Phase spectrum must be linear function of frequency. Magnitude spectrum must be constant. Phase spectrum must be linear function of frequency. Whenever the magnitude is not constant, we will say that as magnitude or amplitude distortion. Phase is not a straight line, means phase or delay distortion. They are combinedly called as linear form of distortion. They are combinedly called as linear form of distortion. Why the phase graph is linearly decreasing? What is this expression? Minus omega t naught means, is it a negative ramp or positive ramp, brother? Plus omega means rising. Minus omega t naught means negative ramp. So it is a straight line with negative slope, sir. Slope is minus t naught. Slope is minus. Magnitude spectrum constant. Magnitude spectrum constant for all frequencies. Phase spectrum must be linear function of frequency. That is what we are saying. Magnitude is constant, phase is linear. But whatever the conditions we have stated here, whether they are practically satisfied or not, let us verify, sir. Observe here. First condition is compulsory requirement for audio amplifiers. Audio systems need constant magnitude. Second one is compulsory for video amplifier and digital communication system. Second one is compulsory for video and digital communication. First one is compulsory for audio amplifiers. In the case of audio system, whether we have linear phase or non-linear phase, we don't bother, sir. In the case of audio system, whether we have linear phase or non-linear phase, we don't bother. Because human ear is insensitive to phase variation. Our ear cannot recognize phase variation. It can recognize only amplitude variations. Human ear is insensitive to phase variations. Human ear is insensitive to phase variations. It can recognize only amplitude variations. It can recognize only amplitude variation. It cannot show any phase variation for us. Because the dynamic range of human ear is practically more than 120 decibel. Dynamic range means maximum amplitude to minimum amplitude. That is called as dynamic range, sir. The dynamic range of human ear is more than 120 decibel. Actually, why this statement came, I am giving a general example, listen. the average duration of each letter or each syllable we are speaking from one person mouth to another person ear. From one person mouth to another person ear, the words are received by this much amount of delay, 0.1 to 0.01 seconds. If you say something, it is audible to other fellow with this much amount of delay. Of course, now we are going with online coaching. For us, at least 5 to 10 seconds delay will be there. Whatever I am speaking, maybe it is audible for you after 4 or 5 seconds only. Okay. So the average duration of each syllable or letter, whatever we are speaking, from one person mouth to another person ear, the words are received by this much amount of delay. But what speech processing engineers have observed is, if they consider phase response also into consideration, they observed the delay to be 1 microsecond, which is not in the tolerable limit, sir. What is the tolerable limit? 0.1 to 0.01 second, but it is outside the range. So they started neglecting phase response. They started neglecting phase response. Okay. They started neglecting phase response. The average duration of each letter, whatever we are speaking, is from one person mouth to another person ear. From one person mouth to another person ear, the words are received by how much delay? 0.1 to 0.1 to 0.01 second. That is the amount of delay caused for audibility. But speech processing engineers have observed that the amount of delay is 1 microsecond. So which is not in the tolerable limits. That is the reason we are neglecting phase variation in the audio system. Easy way to understand, one general example I am giving. Whenever I am discussing the word energy and power signal, my style of utterance is power. I am uttering like power. Some other fellows may utter the same word like power. That is like a foreign accent. Instead of power, they may utter the word power. So whether you utter the word power or power, finally we are recognizing what we are saying, but they will show different phase response curve for you. Power will have certain phase response curve, but power will have different phase response curve, but amplitude recognition is same. So in the case of audio system, it is compulsory. When you are listening to music players, sir, Bose system, Sony, Panasonic, you observe backside of the amplifier, some decibel gain will be mentioned, 60 dB, 80 dB gain. This number will be mentioned. It means it is nothing but K. It is nothing but that K multiplier. It is the maximum tolerable gain you can maintain for that system. If you take any value more than that, the system is spoiled. Any standard audio system you take, Sony, Panasonic, Bose, any company, backside of the power amplifier, depending on its wattage capacity, some gain is mentioned. This number is mentioned. It is nothing but K. If you take any value more than that, the system is spoiled. If you take any value more than that, the system is spoiled. Why we require linear phase? Here I have written video amplifier and digital communication. We require linear phase. Why we require that? Let me explain. See, any image we know as combination of pixels. Assume we try to transmit this image. Any image is combination of pixels. After transmitting this image, suppose at the receiving end, if we have detected the same image like this, this is the transmitted one, this is the received one. What happened? Original image was corrupted. Why it was corrupted means, if we are not having perfect synchronization between the pixels we are transmitting, if we are not having perfect synchronization between the pixels we are transmitting, there is a deviation in the graph. This point also you can understand whenever we are watching live shows. Suppose we are watching live cricket, sir. One general example to give. Suppose you are watching live cricket. Certain times the picture will be stopped over a short duration of 10 or 20 seconds. Over a short duration of 10 or 20 seconds. Over that short duration, the image will look like blurred image, no clarity for us. Means over that short duration, pixels of the image are not perfectly synchronized. So in image processing, linear phase is compulsory. What is the indirect meaning of linear phase? Every pixel amplitude must be perfectly synchronized with other pixel. Otherwise, you will get a corrupted image like this. Why we need in digital communication means, Assume we have transmitted the data in the form of ones and zeros. Assume, sir. But we received the data in the channel like this. If we received the data here like this, what happened here? Error has occurred at second place. 0 becomes 1. Bacha, what is there in what is the error in digital? 0 becomes 1, 1 becomes 0. Our enjoyment is probability of error. Derivations are not bit error rate, probability of error. Why we are getting this problem is, if the amount of delay is more than the required, this symbol may be misplaced by next symbol, sir. 101 may represent some amplitude, but now it changes to a new amplitude. Means you are saying something, you are listening something else. You are saying something, you are listening. So in digital communication also, we have to check that whether every bit with simultaneous bit is obeying linear phase condition or not. Actually, this problem we are learning at phase shifting keying techniques, PSK. 1 bit error leads to 2 bit errors. There we are learning this problem at PSK. 1 bit error leads to 2 bit error, syndrome decoding. These are the techniques in communication. Okay. Just I am giving examples for you. Magnitude response constant is a requirement for audio system. Linear phase response, straight line, linear phase angle is requirement for video and digital communication. In signal processing language, constant magnitude is possible generally with IAR filter. Linear phase response is possible with FIR filter. Constant magnitude is possible with IAR filter. Linear phase response is possible with FIR filter in signal processing language. Okay? In signal processing language, constant magnitude may be achievable with IAR system. Linear phase response is achievable with FIR system. Okay? Yes. Parity bits are added generally. Suppose you are playing a particular song, sir. What is that song number? What is the length of the song? How much duration it is played? To show that parity bits are added. Anyway, once if you are a ES fellow, later on I will show all that emotion, that application part, speech, audio, radar, signal processing uses. Let us not deviate today. Today our emotion is learning distortionless condition. Everyone say with me, what is distortionless condition? Means magnitude spectrum must be constant, phase spectrum must be straight line. Magnitude spectrum is constant, phase spectrum must be straight line. But whatever the conditions we stated here, whether they are practically satisfied or not, that point only we are checking now. We are saying magnitude response is constant for all frequencies, then only distortionless system, then only distortionless condition is obeyed or not. But we studied Parseval's theorem. From Parseval's theorem, how much energy is needed to maintain constant magnitude, sir? If we apply Parseval's theorem, how much energy we need to maintain constant magnitude? What is the energy in that magnitude spectrum? Come on, friends. It is constant over what range? Minus infinity to infinity or not? 1 over 2 pi integral minus infinity to infinity k whole square d omega mod h omega whole square means k whole square. How much energy? Infinity is the energy. Is it possible for us to maintain infinite energy in real life? Very good. Most of you have answered. Is it possible for us to maintain infinite energy in real life? Not possible, which indirectly means maintaining constant magnitude spectrum for all frequencies is also not possible. If you are unable to maintain infinite energy, maintaining constant magnitude spectrum for all frequencies is also not possible. For that reason, we are limiting that constant magnitude spectrum to a specific band. We are limiting that constant magnitude spectrum to a specific band minus omega c to omega c. After that, we are neglecting the higher frequencies. Already what we proved in Fourier series, sir? Maximum energy or power of any signal is there only in which region? Low frequency region or not. So even if you neglect high frequency components, nothing we are losing. Even this is desirable. Even this is desirable. There is a problem with this system. Everyone tell me, Last 2 or 3 days, our emotion is this function only. Rectangular spectrum in time, rectangular spectrum in frequency domain means what is the time domain function answer, sir? We have taken rectangle means what is the time domain function answer? SAF function or sinc function. Very good. SAF function or when you try to draw the impulse response, of course, I have taken modulus, don't be tensed. When you try to draw the impulse response, the graph will appear like this. Rectangular spectrum in frequency domain corresponds to time domain, SAF function or sinc function or not? SAF function or sinc function. This is looking like causal or non-causal. Impulse response in time domain is looking like causal or non-causal? Non-causal, because it covers in the time domain from minus infinity to infinity. So till now at so many places we studied this as which filter? Ideal low pass filter. Every ideal filter is non-causal and unstable. Every ideal filter is non-causal and unstable. How we learn stability of LTI systems are integral of mod h tau d tau less than infinity, but absolute area of SAF function becomes infinity. It is not normal area. Normal area of SAF function finite only. Absolute area becomes infinity because it is never touching negative side. It is never touching only positive amplitude. It is tending to infinity. Absolute area becomes. Every ideal filter is non-causal and unstable. Every ideal filter is non-causal and it is also said as physically unrealizable. Non-causal is also said as what, sir? Physically unrealizable. As ideal filters are not possible for us, we are designing practical filters by using both passive and active components. As ideal filters are not possible, we are designing practical filters by using both passive and active components. RC RLC network theory using op-amp analog. RC RLC generally network theory using op-amp is analog. One well-known example for everyone. If I choose a simple RC network like this, sir. If I choose a simple RC network like this, first order low pass filter, every one of you know magnitude response practically is roughly like this or not? Magnitude response curve is roughly like this, sir. Come on, friends. Roughly the graph is like this or not? Here our target is checking at least up to the cutoff value whether we are maintaining constant magnitude or not. At least up to the cutoff. The design of this practical filter is based on which concept? Ideal filter. Ideal filter is the benchmark because of which we got practical filter. Ideal filter is the benchmark because of which we got practical filter. Every subject you are learning ideal system, ideal op-amp to practical op-amp, ideal voltage source, ideal current source to practical, ideal sampling to practical sampling, ideal filter to practical filter, ideal VA characteristics, practical VA characteristics. Ideal means maths, mathematical enjoyment. Ideal systems cannot be designed. Every ideal filter is what? Non-causal and unstable or not? Tell me. The other way of explanation, why ideal filters cannot be designed, everyone see here, sir. This is pass band, this range is stop band. Pass band to stop band gap is called as a transition band. Pass band to stop band gap is called as a transition band. This gap, pass band to stop band gap is called as transition band. Transition band is deciding the order of the filter. This gap is deciding the order of the filter. Order means number of storing elements. See the cursor. Order means number of storing elements. If you have more width, order less. Come back to our ideal filter, sir. In the case of ideal filter, what is the transition width? 0. Transition width. Pass band suddenly drops to stop band. Sharp cutoff. If you want 0 transition width, we require minimum 1 lakh order filter. Almost like a lorry. Then it is not a filter, it becomes a lorry only. Why physically ideal filters are not possible means because it is asking for impractical size. Because they are asking for impractical size to achieve that characteristics. Okay. Wherever we are using the word ideal filter, it means we are doing mathematics, but they are the benchmark because of which we got practical thought. They are the benchmark. Every subject, first we are learning ideal characteristics, then we are going for practical forms. Okay. So what is the main observation you have to make, everyone? Ideal filters nature is what? Non-causal and unstable. Instrumentation bachas, this question is asked so many times for you. Theoretically, every ideal filter is non-causal and unstable. Non-causal, other meaning is what? Physically unrealizable. Physically, why I am saying unstable, sir? The absolute area under impulse response is infinity. That is the reason we are designing practical filters with passive and active components. And one more observation we have made here is what? Transition width is deciding order of the filter. Transition width is deciding the order of the filter. Order means number of storing elements. Order means number of storing. More transition width means order is less. Pass band to stop band gap. This pass band to stop band gap is called as transition width. If transition width is more, what is lesser? Order is less. More transition width, order is less. If you want to decrease the transition width, number of components will increase. Number of components. So in my discussion till now, what is the point of observation? First slide we stated that for a distortionless transmission, we require constant magnitude spectrum. But whether it is physically possible or not, that point we have checked here. According to Parseval's theorem, energy needed for that system is infinity. We cannot maintain infinite energy in real life. We cannot maintain infinite energy in real life. For that reason, we have limited that to a band gap. After omega c, we can neglect the frequencies because already we proved maximum energy or power is there only in the low frequency region. Even this is desirable. What is the problem with this, sir? Rectangle inverse Fourier is SAP function or sinc function, which is there for all time. It is non-causal and unstable. That is the reason we are designing practical filters by taking both passive and active components. Where ideal filters are possible? For writing competitive exams, they are possible because we have to solve the problems easily. Physically, they are not possible. Physically, they are not possible. Okay? Ideal filters are possible to enjoy the problems easily. That is the reason you see GATE and IES papers. Any subject, they will say, assume ideal characteristics. For our easiness only. For that only, we feel, oh, this year also exam paper is difficult. We are struggling a lot. Okay. Ideal filters only, generally they will mention, sir, practical questions are hardly 1 or 2 in any paper. Maximum ideal characteristics only they will provide. So the conclusion point is what, sir? About magnitude spectrum, our observation. All ideal filters are non-causal and unstable. They cannot be designed. Physically unrealizable means they cannot be designed. All ideal filters are non-causal and unstable. One more point we checked here is pass band to stop band gap is called as transition band. That is deciding what for us? Order of the filter. Order of the filter. Order means number of storing elements. Pass band to stop band gap is called as transition band. That is deciding order of the filter. Number of storing elements. Okay. That is about magnitude spectrum. What is the second characteristic we are expecting? What is the second characteristic we are expecting, sir? Phase spectrum must be straight line. Phase spectrum must be. Everyone should listen carefully. The explanation, based on this only, we have to solve the problems. Listen the explanation carefully, sir. Our expectation is linear phase, but no practical system will satisfy linear phase for us. No practical system will satisfy linear phase. When you draw phase angle versus frequency in normal voice processing intelligibility of the signal is in what range? 300 Hz to 3400 Hz. We are going to observe the phase response versus frequency curve like this. It is not created by me. Don't be tensed. International Telecom Union, they have given that graph. ITU, International Telecom Union, they have given that graph. It is not created by me, sir. Okay. Our expected curve is what? In slide 3, we said linear phase is expected. But what is the shape we are getting? Non-linear shape we are getting. So in the process of converting this non-linear phase response to linear phase response, they have defined two parameters. One is called as phase delay. One is called as phase delay. The delay that is occurring at a single frequency is called as phase delay. The delay that is occurring at a single frequency is called as phase delay, which is given by this relation. It is the delay occurring at a single frequency. How we got that expression? Let me explain. How we are representing a carrier signal generally, cos omega t or sin omega t or not? Carrier, cos omega t or. Once it is transmitted through channel, certain amount of phase angle may be introduced, phase lag or phase lead. What happens if I take omega common here, sir? T plus theta by omega, that is looking like cos omega into t minus tp. See here, everyone. Assume this is the transmitted waveform and the dotted signal is the received waveform, sir. What is the amount of deviation that is caused between the transmitted waveform and received waveform? That is representing phase delay. Why it is function of frequency over the channel width that is measured. Over the channel width that is, if cos omega t is the waveform we are taking carrier, once it is transmitted through channel, certain amount of delay it will cause. How it is causing? Adding extra phase angle. If I take omega common, t plus theta by omega, cos omega t is the transmitted signal, cos omega into t minus tp is the received signal. So what is tp relation? Minus theta omega by. So phase delay is due to carrier. It is due to carrier. So instead of phase delay, we can also say that as carrier delay. Instead of phase delay, we can say that also as carrier delay. Instead of phase delay, what is the other name, sir? Carrier delay. But it is not the true signal delay. Even we defined this, it is not the true signal delay. The reason is, this mathematical relation cannot convert a non-linear graph to linear graph. This mathematical relation, whatever the phase delay formula we have taken, it cannot convert a non-linear graph to linear graph. For that reason, they have defined the second parameter that is called as group delay or envelope delay. Group delay or envelope delay. Listen first. So Tg of omega equals to minus d theta omega by d omega. Minus d theta omega by, it is the delay that is occurring at, it is the delay that is occurring at a group or narrow band of frequencies. A group or narrow band of frequencies. Carrier doesn't contain any information. It is used only for modulation. Finally, in the detection, as we have to detect message signal, so group delay is required. Group delay will tell us how much the modulated signal is deviated from envelope of the message signal. Group delay will tell us how much the modulated waveform is deviated from envelope of the message signal. How to understand this differentiation logic here is, instead of checking one frequency, we are dividing this into small group of frequencies. Everyone observe the slides here. Instead of checking one frequency, we are dividing this to small group of frequencies. First we'll take 300 to 350, sir. First we'll take 300 to 350. Check approximately whether it is straight line or not. Next go for 350 to 400. Check approximately whether it is straight line or not. Somehow we must convert the non-linear graph to linear graph. For that differentiation is needed. What is the indirect meaning of this differentiation, sir? Suppose I have taken a band like omega 1 to omega 2. What is the indirect meaning of this one? Theta of omega 2 minus theta of omega 1 by omega 2 minus omega 1. If I take a band like omega 1 to omega 2, what is the indirect meaning of differentiation? Theta of omega 2 minus theta of omega 1 by omega 2 minus. By dividing the entire frequency region into small group of frequencies, we have chance of approximating the non-linear graph to linear graph. Roughly speaking, it is like a parabola, omega square form. What is differentiation of omega square? 2 omega means we are achieving straight line or not? We are achieving straight line. So group delay is also called as envelope delay because it is retaining the envelope of the message signal. Negative sign in the formula indicates any phase lag that is present in the system. In both formulas, we have negative sign or not? Negative sign indicates any phase lag present in the system. Phase lag, phase lead. Real-time systems lag will be there. Non-real-time system lead will be there. Negative sign indicates any phase lag present in the system, sir. This group delay is one of the parameter regularly that is used whenever a new TV channel is launched. Everyone observe me. Whenever a new TV channel is launched, always they will mention what is the frequency to be tuned, what type of modulation is used, 8 array PSK or something like that. Apart from that, they will also give us group delay as one parameter. They will also mention group delay as one parameter. Suppose they say group delay as 2 microseconds, sir. Assume. If they say group delay as 2 microseconds, what does it mean? What does it mean is, original TV station is transmitting the signal at 7 o'clock. If you assume our TV systems, our home systems are receiving after how much amount of delay? 2 microseconds delay. Original TV signal may be transmitted at 7 o'clock, but our TV system, home systems are receiving after 2 microseconds. That is what group delay. That is what group delay. Instead of checking only one frequency for group delay, what we are checking? Multiple frequencies, narrow band of frequencies. What is the purpose of defining these two parameters is, listen everyone. After designing a modulator and demodulator, the communication engineer job is over the channel width. Over the channel width, they are measuring these two readings, phase reading, what is the phase delay and group delay at every frequency. If they are like milliseconds or microseconds, they will feel they have designed the best system. If they are like seconds, we have designed worst system. Okay, that is called as DUT, device under test. If you see any TV channel is not directly launched, first they will give 1 month free subscription to see whether the signals are transmitted or not properly. So group delay is one standard parameter that is regularly used in every practical system. One example to say, if group delay is 2 microseconds, what you have to understand, the modulated waveform may be transmitted at a time like 7 o'clock, but our home systems are receiving after how much amount of delay? After 2 microseconds delay. After designing a communication equipment, whether it is good or bad, or fast or slow, whether it is a sluggish system or fast system, how to understand? They will prepare this chart. At every frequency over channel width, they will take 2 readings. They will take 2 readings. If they are like milliseconds or microseconds, they feel they have used 100% good components. If they are like seconds also, they will feel they have used worst components. Okay. Anyway, this much build-up is not needed for you. Unnecessary overaction. You just understand what is the meaning of phase delay and group delay. Phase delay is due to a carrier. Phase delay is due to carrier, which is given as minus theta omega by omega. Group delay is minus d theta omega by d omega. Instead of taking one frequency, we are dividing the entire range into small groups to approximate the nonlinear graph to linear graph. I hope from this graph, you may understand something. The difference between phase and group delay. Listen here. Assume this is the modulated signal we have, sir. Message signal embedded on carrier. Assume. We want to transmit this waveform through the channel. After some time, the same graph is going to appear at a different place. The same graph is going to appear at a different place. So how to check phase delay and group delay here is, everyone listen here. If I take this segment of carrier as reference, everyone see the cursor. If I take this segment of carrier as reference, that is retained at a different place. That gap is called as phase delay. That gap is called as phase delay. What is group delay significance, sir? How much the modulated signal is deviated from envelope? How much the modulated signal is deviated from envelope? Suppose if I am taking this segment as reference, that is retained at a different place, that gap is called as group delay. So we are going to measure these readings until we receive the signal. What for we are measuring this? What for they are preparing this table, sir? Whether the considered system is having fast response or slow response. That is what generally named as device under test. That is what generally named as device under. If I take this segment of carrier as reference, that is retained at a different place, that gap is called as phase delay. This dotted signal is envelope of message signal. How much the modulated waveform is deviated from the envelope? This gap is called as group delay. Here I have shown with for one instant, one shift. Like that, at every frequency, we have to measure the readings. Okay? Leave that story, we require formulas. What is phase delay formula is minus theta omega by omega. What is group delay formula? Minus d theta omega by d omega. Minus d theta omega by d omega. Everyone observe here. EC fellows, they can recognize. Phase velocity, group velocity is one common term we are learning in electromagnetics. Phase velocity, group velocity. What is phase velocity formula, sir? Omega by beta. Phase velocity formula omega by beta. What is group velocity? D omega by d beta. Similar appearance. Phase velocity omega by beta. Group velocity d omega by d beta. We are measuring these two to know whether the designed system is having fast response or slow response. To check that point, we are finding out these two. Negative sign is indication of what, sir? Any phase lag that is present in the system. In both formulas, negative sign is indication of phase lag that is present in the system. Phase delay can be also called as carrier delay because it is due to carrier. Group delay can be also called as envelope delay. Group delay can be also called as envelope delay. They are simply looking like phase velocity, group velocity formulas. Those who have remembered electromagnetic subject, recollect. Phase velocity omega by beta, group velocity d omega by d beta. Similar appearance. Similar. Their velocity, here delay. So here I have explained a rough graph how to differentiate phase and group delay. How to differentiate. Till now, theoretical explanation is over about magnitude and phase spectrum. Let us solve few examples on this concept. One point we verified is what, sir? All ideal filters are non-causal and unstable. That is the reason we are designing practical filters. But practical filters can be designed only based on transition width because it is deciding the order of the filter. One more observation we have made about phase response is what? No practical system can have linear phase. In the process of converting non-linear phase to linear phase, we require one of the parameter. Okay. Let us discuss few models related to this topic. Few models. Everyone study this question and answer me. Study this question, sir. Consider a transmission system with magnitude and phase response shown in figure. Mod h omega, angle h omega curves are given, sir. When you are applying input as 2 cos 10 pi t plus sin 26 pi t, when these two inputs are passed through this system, what is the output? Sinusoidal input will guarantee what output for us? Sinusoidal output. Enjoy. Enjoy the question. Sinusoidal input will guarantee sinusoidal output. Come on, come on. Solve and tell me. What is the answer? Sinusoidal input will guarantee sinusoidal output. Whenever you are applying A cos omega naught t plus theta form to a system, h omega, which is having certain magnitude as well as phase angles. So the steady state output is A into mod h omega naught cos omega naught t plus theta plus angle h omega naught. Directly at the input frequency, what we are introducing, once it is processed through system, magnitude change and phase change we are introducing. So respond everyone. What is the possible answer here? Very simple problem. Come on, come on. In our example, input applied is 2 cos 10 pi t. Second term, sir, sin 26 pi t. Means what are the two frequencies, sir? 10 pi and at that frequencies we are introducing magnitude and phase change or not? At that frequency we are introducing magnitude change and everyone look at the graph. At 10 pi, what is the magnitude level? First frequency 10 pi, what is the magnitude level? 2. Originally 2 into 2 cos of 10 pi t. Original number 2, sir. Mod h omega also 2. What is the extra phase angle to be added? When you look at the phase response curve, at 30 pi, how much phase angle is there, sir? At 30 pi, how much phase angle is there? So for 10 pi, what is the phase angle? 10 pi into minus pi by 2 divided by 30 pi. 10 pi into minus pi by 2 divided by means minus pi by 6. Minus pi by 6. At 10 pi mod h omega, see the cursor, at 10 pi mod h omega is 2. Similarly, at 10 pi, what is the phase angle? 30 pi minus pi by 2 means 10 pi how much? Minus pi by 6. Our second frequency 26 pi, sir. What is magnitude for 26 pi? What is the magnitude number? 1. Originally also 1. 1 into sine of 26 pi t. How much phase angle to be added? Same enjoyment. 30 pi minus pi by 2 means 26 pi how much? For 30 pi minus pi by 2 means 26 pi how much, sir? 26 pi into minus pi by 2 by 30 pi. X1 is giving y1, x2 is giving what? For 30 pi minus pi by 2 means 26 pi how much? 26 pi into minus pi by 2 divided by 30 pi. This is not the first time we are solving the problem, but this is the first problem we have taken phase response also into consideration. Till now, constant gain. Blindly we have chosen constant gain or not. From Fourier series onwards. Input sinusoidal means output is sinusoidal. Steady state response, YSS, means steady state response. Directly at the given frequencies introduce magnitude and phase change, magnitude change and phase change. The graphs are visible for us, sir. Graphs are visible. Most of you have given correct answer. I hope everyone completed the last model. Directly introducing magnitude and phase change. Directly introducing the magnitude and phase change. Okay, let us go for next model. For a linear phase channel, what is phase and group delay is the question. For a linear phase channel, what is phase delay and group delay is the question, sir. If you take linear phase channel, what is phase delay and group delay is the question. How we discuss linear phase words, sir? Go back to our third slide. What is linear phase meaning? Minus omega t naught. Linear means straight line or not? Minus omega. So theta of omega equals to minus omega t naught. Means linear phase. Theta of omega equals to minus omega t naught means what is phase delay relation? Minus theta omega by omega, simply t naught. What is group delay relation? Minus d theta omega by d omega, that is also t naught. That is also, so phase delay and group delay are constant. Linear phase means phase spectrum straight line. Phase spectrum straight line. The general form we know as minus omega t naught. Substitute in phase and group delay formulas. What is phase delay formula? Minus theta omega by omega, sir. Group delay is minus d theta omega by d omega. Both are equal and constant. Both are equal and constant. Group delay constant means for different frequency bands we are selecting. For different frequency bands we are selecting, we will get equal amount of delay. Group delay constant meaning is for different frequency bands we are selecting, we will get equal amount of delay. That is the meaning of group delay is constant. For different frequency bands we are selecting, we will get equal amount of delay. That is what group delay is constant means. Now you try this right side question. That is another funny question. Suppose a transmission system has frequency response as shown in figure. For what range of frequency there is no distortion? Mod HF means magnitude response, argument. ARG means argument angle HF. Both are given. For what range of frequency there is no distortion? No amplitude distortion for what range, sir, from the graph? No amplitude distortion for what range? 20 to 50 kilohertz, there is no amplitude distortion or not. Constant magnitude is there, 20 to 50. No phase distortion for what range? No phase distortion. Phase spectrum is straight line only for which range? 0 to. No form of distortion for what range? No form of distortion for what range? Tell me. 20 to 30. Because for distortionless transmission, what is the condition to be satisfied? Magnitude spectrum constant, phase spectrum must be linear. So 20 to 50 range. If you see the cursors are 20 to 50, no magnitude or amplitude distortion. 0 to 30, no phase distortion because we want straight line. Both forms of distortions are not appearing only for 20 to 30 kilohertz. 20 to 30 kilohertz. Okay. Good. Very good. Just a minute. Yes. Think about this question. System under consideration is an RC low pass filter with R equals to 1 kilo and C equals to 1 microfarad. H of F denote the frequency response of the RC filter. And it is stated F1 is the highest frequency component. Mod H of F1 by mod H0 greater than or equals to 0.95. How to get that unknown frequency F1? Think and answer me, sir. For RC filter, what is the standard transfer function or frequency response? 1 by 1 plus j omega RC. 1 by 1 plus j omega. So mod H of F becomes what? 1 by root 1 plus 2 pi f RC whole square, such that mod H0 is 1 or not? F place 0. F place. So this condition changes to what, sir? Mod H of F1 greater than or equals to 0.95. Mod H of F1 greater than or equals to point. Denominator is 1. Mod H0 is. What is there, bacha? Inside the square root, only F is unknown, sir. Substitute here. Inside the square root, only F is. So 1 by root of 1 plus 4 pi square F1 square. What is RC product? See here, see the cursor. 10 cube into 10 power minus 6. 10 cube into 10 power minus 3 volts. solve for F1 number. Later on, don't get emotion immediately. You can take direct equality also. Greater than or equals to means you can take directly equality also, because it is a maximum frequency that is available. Mod H0 is 1. Mod H0 is 1. Directly substitute in the square root. Directly substitute in the square root. Okay. Don't apply seriously 1 by 2 pi RC formula. Don't apply seriously 1 by 2 pi RC. That is 3 dB cutoff. 3 dB means magnitude is 1 by root 2. 3 dB means magnitude 1 by root 2, sir. How to answer the second bit? Let Tg of f denote the group delay of the filter. We want its value at 100 Hz. Group delay means we know it is differentiation of phase angle. Group delay meaning is differentiation of phase angle. Everyone tell me, what is the phase angle of this filter? 1 by x plus jy means what is the phase angle of this filter, sir? Minus tan inverse y by x. Minus tan inverse y by x. Imaginary by real term. So, phase angle of that filter is minus tan inverse of 2 pi f RC. Minus tan inverse of 2 pi f RC. Phase angle of the filter is minus tan inverse of. Calculate the group delay now. Calculate the group delay. Tg of f equals to minus d theta f. D omega can be written as 2 pi df or not, sir? Denominator. Our relation is minus d theta omega by d omega. Denominator d omega is 2 pi df. 2 pi df. It means it is minus 1 by 2 pi d by df of minus tan inverse 2 pi f RC. What is d by dx of tan inverse x, sir? It is looking like d by dx of tan inverse x. Do that enjoyment. D by dx of tan inverse x is 1 by 1 plus x square. D by dx of tan inverse x is 1 by 1 plus. So 1 by 1 plus 2 pi f RC whole square. Then differentiation of the bracket term is what? Minus 2 pi RC. 2 pi jump. We want the group delay at 100 Hz. Every quantity is known, substitute. We want the group delay where? Where it is asked, sir? 100 Hz. 100. So numerator RC product is what? 10 power minus 3. 1 plus 4 pi square. 100 whole square. 10 power minus 3 whole square. Substitute every known quantity there. If you do simplification, 0.717 milliseconds is the number. D by dx of tan inverse x is 1 by 1 plus x square. D by dx of tan inverse x is 1 by 1 plus x square. Only mathematical substitution. How we got phase angle? Who is that bacha? 1 by x plus jy minus tan inverse y by x minus tan inverse of imaginary by real, y a phase angle. RC filter transfer function also you don't know. RC filter transfer function 1 by 1 plus SRC j omega RC like that. What is the meaning of this 0.7 milliseconds? Answer we got here is the modulated signal and message signal are deviated by 0.7 millisecond. It means if they transmit the signal at 6 o'clock, when the signal is received 6 o'clock plus 0.7 milliseconds, which is a negligible number. Why we got that negligible number means everyone see our previous slide. What is RC element numbers in the question? 1K and 1 microfarad. 1K and 1 microfarad. That is the reason this is negligible numbers are. Suppose in our question R equals to 10 ohm, C equals to 10 farad. R equals to 10 ohm, C equals to 10 farad. If you solve the same question, group delay may be 3 hours. Means now you give input, watch a movie and come back. With you output is coming. That means we have designed a wonderful verse system or not? Where you will watch the movie? Only at home. OTT platform, no other chance for us for few days. We must be careful, taking care of our health also. So the purpose of measuring phase delay and group delay, what I mentioned with you. Why we are measuring phase delay and group delay? To decide whether the design system is good or bad. This RC network system is very good. 1K 1 microfarad, which has provided at this frequency only 0.7 milliseconds delay. But if you choose in the same question like R number as 10 ohm, C as 10 farad, you may get group delay as 3 hours. Means it's a worst system we have designed. It's a worst system. Now everyone try the right sided question. Try the right side example, everyone. Come on, sir. Try the right-sided example. Mod HF argument means phase angle given, input is sinusoidal. What is the average power of the output signal? Same as our first example. This example, same logic. Think and answer me. We want the average power in the output. Very simple problem. Sinusoidal input, sinusoidal output, sir. Come on. What is the average power in the output? Is the question. Magnitude response is a symmetrical triangle. Minus 20 to 20. Mod HF is a symmetrical triangle. That is the meaning of 1 minus mod F by. Phase angle is mentioned as what? Minus 2F. Minus 2F. See everyone. What are the frequencies we have? 20 pi means F1 is 10 Hz. F2 is 20 Hz. F3 is 40 Hz. They are omega form, F form. Which frequencies are there? 10 Hz, 20 Hz, 40 Hz. Which component can be retained at the output? Only 10 Hz can be retained. 20 also jumps are because at 20 what is mod HF number? 0. Second frequency, third frequency, no chance. Introduce the magnitude and phase change. 8 into 1 by 2. For 20 units, 1 means 10 units, 1 by 2 or not. Amplitude level, magnitude level. 20 units, 1 means 10 units. Cos of 20 pi t plus pi by 4 plus theta. Don't bother about phase angle. That fellow has asked power in the output or not. That is the reason I am leaving it. 8 into 1 by 2 cos of 20 pi t plus pi by 4 plus. So what is the power in the output, sir? 4 square by 2 watts. 4 square by 2. I hope you have remembered that point. Power in the sinusoid. A cos omega naught t plus theta or A sin omega naught t plus theta. A cos or A sin means A square by 2. 32. Who is that 32 fellow? Eight square by 2, sir. Your amplitude scaling is also done. Directly you have taken power in the input is not asked. Average power of the output signal. There is certain amplitude scaling. 1 by 2 scaling. For 20 units it is 1, sir. 10 units it becomes 1 by 2 amplitude scaling. Be careful. Okay. I hope everyone completed the last model. Now think about this question, sir. Analog filter has magnitude and phase characteristics shown below. For that filter, we applied certain inputs and we got some outputs also. Tell what kind of distortion has occurred is the question. For the respect to input-output combination, we should decide what form of distortion has occurred. You calculate theta, you cannot calculate bacha. Minus 2f. Angle HF is mentioned as minus 2f. Substitute that. F place 10 hertz. Add karo, radian ko convert karo. One or two things you should do. 1 plus 1 equals to 2. I want proof means. As anyway power is asked, I have done that. Angle HF is minus 2f. That only we are adding. This is in degree mode. Convert to radian. Phase angle भी calculate करो. आप क्या करते? If I do everything, think and answer me. Mod h omega, angle h omega are given. Respect to input output are also given. In each case, you have to decide what form of distortion has occurred. Everyone check the first input outputs are cos 20t plus cos 60t input. Output side amplitude scaling is same. Means no amplitude distortion. No amplitude distortion. Do we have phase distortion? Do we have phase distortion? Come on, sir. For the first input output, do we have phase distortion? Phase distortion is also not there because if you look at this curve, phase spectrum is straight line for which range, sir? Minus 100 to 100. 20 and 60 are within the range or not? Phase spectrum is a straight line. Phase spectrum is a straight line from minus 100 to 100, 20 and 60 are within the range. Luckily, here that graph is given. If the graph is not given, how to decide whether phase distortion occurs or not? Everyone check here. We mentioned minus omega t naught means phase spectrum is straight line. You concentrate output for y1t. If I take 20 frequency common, If I am taking first frequency common, what is the amount of delay, sir? Pi by 200. If I take 60 frequency common, what will happen if I take 60 frequency common? So what is the amount of delays are? Frequency can differ, delays are same. Cos omega into t minus t naught. Here pi by 200, here pi by 200 means slope is same or not? Take the respective frequency common, it must appear like omega into t minus t naught form. Amount of delays are same. Luckily in the example graph is given, sir. With the graph we can say no phase distortion. Suppose this graph is not given, what is our emotion? Take the respective frequencies common, amount of delays t naughts must be same. Here pi by 200, here also pi by 200. So first input output no distortion. First input output no distortion. Second combination respond. Second input output. No amplitude change. Here 1 1, here also 1 1. No amplitude change. But phase distortion occurs. How to check? Just like this. If I take 20 common here, pi by 200 is the slope. If I take 140 common, pi by 280, they are not same. Pi by 200, pi by 280. Sorry, no amplitude distortion, but phase distortion occurs. Second input output, phase distortion occurs. Why? If you take 20 common, pi by 200, if you take 140 common, pi by 280. Respond the last combinations are everyone. Respond the last combination. Input side amplitudes are 1 1, output side 1 2. They are not scaled by same factor. Means amplitude distortion occurs. Amplitude distortion occurs. Phase distortion also occurs. How I am saying? If I take 20 common, pi by 200, see the cursor. If I take 20 common, pi by 200, if I take 220 common, pi by 440. 20 common, pi by 200, 220 means pi by 440. First input output, no distortion. Second combination, only phase distortion. Last combination, both amplitude and constant magnitude means everywhere same multipliers are, not according to your convenience. Certain range 1, certain 2, certain range 2. Everywhere same. Everywhere same. So here magnitude distortion is there, phase distortion is there. One girl got a doubt why you have missed 20 hertz. Idhar dekho ma. Amma. See here. 20 hertz is the second frequency, amma. What is the amplitude level, ma? At 20, 0. 0 into anything is 0. It is gone. Our second frequency 20 hertz. What is mod HF number, ma? Amplitude level 0. 0 into that quantity becomes 0, ma. Okay? For 1.5 hours, we have shown emotion on this distortionless topic. Two things everyone should remember. Only 2 points you have to remember. Say with me, everyone. For a distortionless transmission, what is the condition to be satisfied in frequency domain? Everyone. For a distortionless transmission, what is the condition to be satisfied, sir? Magnitude spectrum constant, phase spectrum must be linear. Magnitude spectrum constant, phase spectrum must be linear function of frequency. Correct or not? Another point is, what is phase delay and group delay formula? Phase delay is minus theta omega by omega. Group delay is minus d theta omega by d omega. Phase delay is minus theta omega by omega. Group delay is minus d theta omega by d omega. Okay? Very good. Last example, I think everybody got emotion very easily. You have answered distortion problem. Okay. Pure signal content, no one will answer. Distortion is there means you are showing your emotion. Good, good. If I discuss distortion problems, then only I think your emotion will come out. Good. Okay. That is the first application topic we completed. First application topic. Let me discuss the second topic. Hilbert transform. Why this is coming? Always disturbing me. Keep it aside. Hilbert transform. Hilbert transform is needed wherever you want additional phase angle of 90 degrees. Hilbert transform is needed wherever we need additional phase angle of 90 degrees. Everyone listen here, sir. Now we are discussing an interlinking concept. From Hilbert transform, we are going for a pre-envelope, which is also called as analytic signal. Pre-envelope is needed when you want to measure the spectrum for positive range. Pre-envelope is needed when you want to take the spectrum for positive range. From here, we are going for complex envelope, where we are going to take in-phase and quadrature components. In-phase and quadrature components. From here only your communication subject starts. One application of Hilbert transform is in the generation of SSB, we want that. Single sideband modulation. Another application is narrow band representation of the signal. Narrow band representation of signals, where we are writing that in-phase and quadrature components. There also we need Hilbert transform. So our journey will go like this. From Hilbert transform, we are creating pre-envelope. From pre-envelope, what we are creating? Complex. A brief introduction already we have seen about Hilbert transform, sir. Under duality, whenever you take system as 1 by pi t, whenever you take system as 1 by pi t, by giving input as xt, output becomes x cap t. Hilbert transform symbol is x cap t. It is called as Hilbert transform of xt. Input x of t, sir, system 1 by pi t. Output is denoted as x cap t. That is called as Hilbert transform of xt. Hilbert transform of x of t. Listen, listen. Observe here. I can write x cap t answer as x of t convolved 1 by pi t. Input known, system known, get the output means convolution. Input known, system known, get the output means convolution. What is the Fourier transform of this expression? I can write, sir, x hat omega equals to xt means x omega multiplied by 1 by pi t means what? Minus j signum of omega. Minus j signum of. It means what is the frequency response of the Hilbert transform is Fourier transform of output by Fourier transform of input, which is simply minus j signum omega. Frequency response definition is what? Output spectrum by input spectrum. Output Fourier transform by input. So what is this answer if I am choosing only positive range, sir? Minus j, signum is plus 1. Signum is plus 1. If I am taking negative range, signum is minus 1, it becomes plus j. What is the magnitude of this one? Magnitude of plus or minus j is what? 1. So the magnitude response is constant for all frequencies. Magnitude response is constant for all. Magnitude is everywhere 1 means it is acting like which filters are? All pass filter or not. So Hilbert transform we are designing indirectly means it represents a all pass filter. Hilbert transform we are designing means indirectly represents. Hilbert transform acts like which filter? All pass filter. What about the phase angle? What about the phase angle, sir? Positive range of frequency minus j means minus pi by 2. Negative range it is plus pi by 2. Positive range minus pi by 2, negative range. As a spectrum is generally considered for positive range, blindly we are adding minus pi by 2 phase angle. As spectrum is generally measured for positive range, blindly we are adding minus pi by 2. Okay. So the system we need is 1 by pi t. Under duality, we studied 1 by pi t spectrum is minus j signum omega. Minus j signum omega. Magnitude of this one is 1. Means Hilbert transform acts like all pass filter, and we have phase angles of plus or minus pi by 2. Phase angles of plus or minus pi by 2. Hilbert transform acts like an all pass filter. Everywhere its magnitude is 1, sir. Hilbert transform acts like an all pass filter. Hilbert transform acts like an all pass filter. Another point is signal and its Hilbert transform are orthogonal to each other because they have 90 degrees phase separation or not. Signal and its Hilbert transform are orthogonal to each other. Signal and its Hilbert transform are orthogonal to each other. Another observation is input spectral density and Hilbert transform spectral density both are equal. Mod x omega whole square equals to mod x cap omega whole square because middle mod h omega how much? 1. That is the reason input and output spectral densities of Hilbert transform are same. Mod x omega whole square equals to mod x cap omega whole square. Input spectral density and output spectral density both are same. Even we are saying the word Hilbert transform, it is not doing any domain conversion like Fourier. Fourier transform means time domain converted to frequency domain, sir. Fourier transform meaning is time domain converted to. Hilbert transform is not doing any domain conversion. Hilbert transform is not doing any domain conversion. It is adding only extra phase angle. So don't have a wrong thought. Transformation means change of domain. Even if you add extra phase angle, that is also treated as transformation. Okay. Hilbert transform is not doing any domain conversion. Hilbert transform is not doing any domain conversion. All pass filter is not there. A single delay is a all pass filter. Who told you? Don't get emotion, bacha. If I take Z inverse, a single delay magnitude is 1. That is all pass system only. Then how communication subject is possible for you? There we are using 90 degrees phase shifter called as quadrature filter. Let us discuss some simple models on this concept, sir. What is the Hilbert transform of cos and sine functions respectively? Very simple question I ask. What is the Hilbert transform of cos and sine function respectively? For positive range, what is the phase angle we are adding? Minus pi by 2 or not for positive range. So cos omega naught t minus pi by 2 means answer becomes sine term. Sin omega naught t minus pi by 2 means answer becomes minus cos. Cos becomes sin, sin becomes minus cos. Cos becomes sin, sin becomes minus. Hilbert transform of cos is sin, sin means minus cos. Be careful, sir. Negative sign is also there. You must be careful, sir. Cos becomes sin, sin becomes minus cos. It means you can say Hilbert transform of a real signal is real. Cos becomes sin, sin becomes minus cos. Hilbert transform of a real signal is real. What is the Hilbert transform of complex sinusoid? E power j omega naught t. I am asking what is the Hilbert transform of complex sinusoid? E power j omega naught t. Eigenfunction logic. See our previous slide. Input e power j omega naught t means output must contain e power j omega naught t. Scaling factor is frequency response. What is frequency response for positive range? Minus j. Input exponential means output also exponential. Scaling factor is frequency response. See the cursor, sir? What is the frequency response for positive range? Minus. Answer is minus j times e power j omega naught t. The other way of enjoyment, e power j omega naught t minus pi by 2. We are adding pi by 2 phase angles, sir. That is e power minus j pi by 2 into e power minus j pi by 2 is simplified as which, sir? E power minus j pi by 2 is simplified as which term? Minus j. E power minus j pi by 2 is simplified as minus. Quadrant. What quadrant, bachchan? Where are the quadrant here? What is the Hilbert transform of impulse function? Let me see how many of you will give correct answer to me. I am not asking Fourier transform of impulse one. Every one of us know. Every one of us know. I am asking what is the Hilbert transform of del of t? Del of t. What is the Hilbert transform? See here, previous slide. Input del of t, system 1 by pi t. Input you are applying del t, system 1 by pi t. What is del of t convolved 1 by pi t? Answer, sir. What is del of t convolved 1 by pi t? Answer becomes 1 by pi t. That is the answer. You are applying input to the black box as del t. Del t convolved 1 by pi t. Answer is what? 1 by in a similar way. If my question is what is Hilbert transform of 1 by pi t? It means I am asking Hilbert transform of Hilbert transform. 2 times Hilbert transform. I am asking Hilbert transform of Hilbert transform. Think. Same means you or me. Same means you or me. No. Only one fellow positive answer till now. Two fellows. See the first two bits, you know the answer. First two bits only you see the cursor. Cos becomes sin, sin becomes minus cos, sir. Cos converted to minus cos. Two Hilbert transforms in series only here. Xt becomes minus xt. Two Hilbert transforms connected in series. Frequency response of each Hilbert transform is minus j signum omega whole square. 1 by pi t convolved 1 by pi t means take the Fourier transform of them, which is simply j square. J square is minus 1. Constant in frequency domain means answer minus del t. Constant in frequency domain. We have taken constant in frequency domain. We observed 1 by pi t spectrum is minus j signum omega, sir. So minus j signum omega into minus j signum omega, which is j square. Constant in frequency becomes minus del t. Actually, x of t becomes x cap t, output becomes minus xt. X of t becomes x cap t, output becomes minus x of t. What is the Hilbert transform of a modulator? Xt band limited to B. B is very much less than omega naught. Generally, omega naught is mega. B is like kilo. What is the Hilbert transform of modulator? Xt cos answer I want. It is not affecting x of t, but for cos, what is the answer we know, sir? It is not affecting x of t, but for cos, what is the answer we know? Sin. Let me explain that point. If I take Fourier transform of modulator, we know x of omega minus omega naught plus x of omega plus omega naught whole divided by 2. Take Fourier transform of that one. So, Hilbert transform meaning is Fourier transform of input multiplied by system response. System response is minus j signum omega or not. This is input now. It is not xt, sir. Xt cos omega naught t. That is extra multiplied by which term? Minus j signum of omega. Minus j signum of. Everyone see here. See the cursor. X of omega minus omega naught means it is right shift or not. Means towards positive range. X of omega minus omega naught means right shift, sir. Towards positive range. Towards positive range, this bracket term is minus j. Means minus j into x of omega minus omega naught. X of omega plus omega naught means towards left shift means negative range. Negative range bracket term is plus j x of omega plus. If I multiply both numerator and denominator by extra j, if I multiply both numerator and denominator by extra j, it will appear like this j multiplier, sir, which is neatly looking like Fourier transform of xt sin. It is neatly looking like Fourier transform of xt sin term. First, everyone see here. This is like xt now, sir. Take its spectrum multiplied by frequency response means minus j signum omega. X of omega minus omega naught means spectrum is shifted towards positive range. Positive range bracket term minus j. X of omega plus omega naught means towards negative range. Bracket term is plus j. Multiply numerator and denominator by j. This is the answer. Without all this build up, what we said? Cos becomes sin. Xt remains same. cos becomes sin. In a similar way, what is the Hilbert transform of xt sin, sir? What is the Hilbert transform of xt sin? Minus xt cos. Hilbert transform of xt sin means minus x of t cos term. Hilbert transform of xt sin means, if the question is what is the Hilbert transform of xt sin omega naught t, answer becomes minus xt cos omega naught t. Minus xt cos omega naught t. Okay. From this Hilbert transform, we are using the concept of pre-envelope. From this Hilbert transform, we are using the concept of pre-envelope. Listen everyone. Pre-envelope of a signal x of t denoted as x plus t, which is original signal plus j times Hilbert transform of the signal. If you want to retain the spectrum only for positive range, we are saying this way. We want to retain the spectrum for positive range because all real functions will have positive sided spectrum. Bandwidth is also measure of positive range, sir. So pre-envelope of a signal means x plus t, which is combination of original signal plus j times Hilbert transform. What is the Fourier transform of this quantity, sir? X plus omega equals to x omega plus j into, what is the Fourier transform of Hilbert? Already we have written this quantity. Fourier transform of Hilbert already we have written as minus j signum omega into x omega. If I take x omega common, minus j square is plus 1, sir. 1 plus signum of omega. So this answer is what? 2 times x omega only for positive range, because positive range signum is plus 1, 0 for. So the pre-envelope of the signal spectrum is retaining our original spectrum only for which range? Positive range or not? When you take pre-envelope spectrum, sir, spectrum is retained only for positive. How to understand this word? See here everyone. Suppose we assumed this as reference spectrum. Suppose we assumed this as reference spectrum. If I ask pre-envelope spectrum, what does it mean? If I ask pre-envelope of that spectrum, try to retain for positive range, but what is the change in the amplitude level? 2 times x0. x0 becomes 2 times. That is what in Fourier series we have learned as what, sir? In the process of converting exponential to trigonometric series, what is the mathematical logic we have learned? Double the magnitude and positive sided frequency angle. Correct or not? That is done mathematically, but physically how it is happening? When you take pre-envelope of a signal, automatically spectrum is retained only for which range, sir? Positive range. Pre-envelope of a signal is original signal plus j times Hilbert transform. I have taken Fourier of this one. So xt means x omega. Fourier transform of Hilbert is this. Minus j square is plus 1. If I take only positive range, signum is plus 1 means 2 times x omega. Negative range, it is 0. This example I have chosen. If my original spectrum is like this, what is the pre-envelope spectrum? Only for positive range, double. 2 times x0. Correct or not? That is called as pre-envelope of a signal. So there is no need to take some examples on pre-envelope because previous slide we solved signal and its Hilbert transform, just mathematical substitution or not, sir? Bacha. Previous slide, we have taken signal and Hilbert transform. One example to say, suppose I asked what is the pre-envelope of cos omega naught t. Suppose here cos omega naught t plus j sin omega naught t. If I ask what is the pre-envelope of cos function, sir, cos omega naught t plus j sin omega naught t means e power j omega naught t or not? Theoretically, we said spectrum is generally retained for positive range because as bandwidth is measure of positive frequency range. But how it is happening means when you take pre-envelope of any signal, then it will happen. When you take pre-envelope of any signal, then it will happen. Actually, from this only we are going for complex envelope. From this only we are going for complex envelope. Listen here. What is complex envelope of a signal? X of t means it is represented as x tilde t. The symbol is called as tilde, not dalda. Tilde. X tilde t. It is nothing but pre-envelope multiplied by exponential term. If you multiply by complex sinusoid, pre-envelope multiplied by, that is nothing but xt plus j times x cap t multiplied by exponential. Of course, if you expand the exponential as cos theta minus j sin theta, sir, separate out cos term, separate out sin term, that is what narrow band representation. For some of you, communication is over. There we are studying that as NCT cos omega ct minus NST sin omega ct or not. NCT cos omega ct minus NST sin omega ct. There the communication subject is starting narrow band representation of the signal. See the link. First we started with Hilbert transform. How Hilbert transform is modified to pre-envelope, sir? Signal plus j times Hilbert transform. How it is modified to complex envelope? xt plus j x cap t multiplied by exponential. If we expand this cos omega ct minus j sin, here our communication subject starts like where we are sketching general modulator block diagram, something like this. I will show you. See here. First we are taking x of t. I am not sketching completely, just listen. Oscillator that will generate AC cos omega ct. Both are multiplied. When you provide here a 90 degrees phase shifter, that will produce what? AC sin omega ct. These two are also multiplied. After that, they are passed through some filters to get the required component. General modulator and block diagram, modulator and demodulator block diagram we are developing in communication. That is linked to which formula? Complex envelope. This is mathematical enjoyment. This is block diagram enjoyment. Okay. This 90 degrees phase shifter is what? Quadrature filter. Hilbert transform. Okay. Don't forget the link. Pre-envelope means original signal plus j times Hilbert transform. It is extra multiplied by e power minus j 2 pi fct means it is complex envelope. If it is extra multiplied by e power minus j 2 pi fct, then it is Abba, tilde, not tilde. Abbo, excellent. Maybe you are preparing for GRE TOEFL. Excellent. Very good. Good correction. Enjoy, brother. This is a miscellaneous topic, sir. In 30 years GATE paper, only one time a question was asked on complex envelope. They will always give questions on Hilbert transform only. Only one time a question was framed on this. Let us discuss that model. Complex envelope model. Okay. This is the question asked. What is the complex envelope of the band pass signal x of t given by that expression centered at 1/2 Hz? Anyway, you know on the left side the relation, complex envelope relation, sir. Xt plus j times x cap t multiplied by exponential. Solve karo. Yes, from pre-envelope only complex envelope is developed, sir. X of t is known, that you have to substitute here. Xt plus j times x cap t centered about 1/2 Hz means fc plus 1/2 you have to substitute for simplification. fc place you have to substitute. One by two. Think and answer me. Anyway, this SAF function remains same. It will not change, sir. I am naming for convenience that as m of t. SAF function remains same. It will not change. Okay. M of t sine. Original signal is m of t sine. What is the Hilbert transform of m of t sine, sir? Minus m of t cos. Minus m of t cos. So, do substitution, tell me the answer. So what is the complex envelope? Now we can write here is, my friend has corrected me, x tilde t. He wants the spelling as tilde. Excellent, hero, Malik. First we have to take original signal. Minus root 2 m of t. I assumed SAF function for convenience as m of t. Sin pi t minus pi by 4. This itself is xt, sir. This itself is xt. Plus j times x cap t. What is the Hilbert transform of this term? M of t sin Hilbert transform is what? Minus m of t cos. Multiplied by that exponential term. In the last step, I will substitute f number. First x of t plus j times x cap t. M of t sin Hilbert transform is what? Minus m of t cos multiplied by exponential. Mathematical simplification, that enjoyment is needed. So what I am doing here is, in this bracket term, I will take minus j m of t common. In this, I will take minus j m of t common. If I take minus j m of t common, here we have only m of t. I should introduce j component or not. In this bracket term which I have written, I have taken minus j m of t common such that it is cos pi t minus pi by 4 plus j into sin pi t minus pi by 4 multiplied by exponential. I have taken minus j m of t common means here I need plus j. Minus j square becomes plus 1. Then only you will get positive sign or not, sir? Multiplied by exponential. Everyone tell me how this is looking like. Cos theta plus j sin theta form or not? So further it is written as j root 2 m of t e power j pi t minus pi by 4. Now I am substituting the given number. F number, we have to check the value at 1/2 or not. It is mentioned in the question, centered about 1/2 H. Check the value at e power j pi t, e power minus j pi t, jump cancellation. Here e power j pi t is there, here e power extra j you can adjust as what? Extra j you can adjust as what, sir? E power j pi by 2. So further answer is what? Root 2 m of t e power j pi by 4. See here pi by 2 is there, here minus pi by 4. Pi by 2 minus pi by 4 becomes what? So root 2, what is m of t in the beginning we assumed? SAF function. SAF function. After substitution, mathematical simplification, you must be careful. After substitution, mathematical simplification, you must be careful. See, sir, first I assumed this as m of t minus root 2 m of t sin pi t minus pi by 4. X cap t m of t sin Hilbert transform is minus m of t cos. Then in the next simplification, minus j m of t common I have taken. After that mathematical enjoyment, f number is given as 1/2. That also we substituted. Mathematics we have done, but the point of observation is this is a band pass signal or not. It is already mentioned in the statement. By taking band pass signal, what you have recovered here? SAF function means that spectrum is from minus pi by 5 to pi by 5. Band pass signal to low pass signal is demodulation in communication. Band pass signal converted to low pass signal means demodulation. Complex envelope has developed modulator diagram. From this mathematical simplification, it also develops demodulator diagram. Maybe it is mathematical formula, but it can create both modulator and demodulator where our communication subject is starting. Modulator and demodulator both are created. Okay. Here from this expression I said this is modulator diagram. We have selected a band pass signal in the problem. What we have recovered, sir? Finally, after simplification, a low pass signal. Band pass to low pass means it is demodulation process or not? One of our friend, he cannot stop his emotion. Let me discuss that point also. He is asking why Hilbert transform of SAF function is not there. Who said to you? You solve on your own, bacha. Sin t by t is Hilbert transform. Sin t by t is SAF function. This is the Hilbert transform you should get. I am giving answer for you. SAF function. If you are unable to solve in time domain, take its spectrum, multiply by minus j signum omega. One more question, 1/t square plus 1, which is linked to two-sided exponential. 1/t square plus 1, that is linked to, this is the Hilbert transform answer. SAF function also contains Hilbert transform. Try 1/t square plus 1 linked to two-sided exponential. Like I mentioned with you earlier, if you fail in time domain, frequency domain available. If you are failing in time domain, what we have to do? Original spectrum multiplied by minus j signum omega. Correct or not? Original spectrum multiplied by minus j. Assignment for you. You can feel that as homework. So this is a simple concept we studied. First we have taken Hilbert transform, that is converted to pre-envelope where the spectrum is retained only for positive range. That is converted to complex envelope where we can develop both modulator and demodulator diagrams that we require in communication subject. Both modulator and demodulator diagrams. Let us go for a short break, 20 minutes. After that we'll start correlation concept. Take a short break, sir. Okay. I hope everyone came back. Yes, sir. Let us start the next application. First application we studied as distortionless condition. Second application is Hilbert transform pre-envelope complex envelope link. Third application is correlation. Actually, it is correlation. Combinedly, we are calling as correlation, sir. Wherever we are observing the similarity between two different signals, we are trying to observe the similarity or coherence between two different signals. That is called as correlation concept, which is of two different forms: autocorrelation function, cross correlation function. Correlation meaning is it is a measure of similarity between two different signals. In autocorrelation, we are comparing the signal with its shifted version. Whereas in cross correlation, we are comparing the signal with another signal shifted version. In autocorrelation, we are comparing the signal with its shifted version. In cross correlation, we are comparing the signal with another. How to understand this word is, see here. Assume this is the transmitted signal we have. Over the channel width, every time we are checking that whether the shifted signal is looking like original signal or not, or do we have any deviation. Whether the shifted version of the original signal is looking like original signal or not. So whenever we are trying to compare the same signals, it is a concept of autocorrelation function. Okay. Whereas what is cross correlation is, assume this is x of t for us, the original signal, but we have detected the noisy version of the same signal, something like this, with certain amount of delay. From this noisy signal, how to get the estimate of the original signal is cross correlation function concept. From the noisy signal, how to get the estimate of the original signal. For that, we are trying to compare the input spectral density and output spectral density. We are trying to compare the input spectral density and output spectral density. For the range of frequency, they are matched to field signal information. Otherwise, it is noisy information. Its main application is the matched filter. Its main application is the matched filter. If the input is x of t, the system response must be folded and shifted version of original signal. The system response must be folded and shifted version of original signal. Why folding and shifting? Let us observe here. If I apply input as rectangle, the folded version of the rectangle is minus t to 0, that is x of minus t, sir. If it is right shifted by capital T units, I am getting h of t. I am getting h of t. Means the system is matching to the input signal applied 0 to t. If I convolve xt and ht, every one of us know convolution of two equal length rectangles means it is triangle. Why folding later on shifting is done means whatever the delayed instant that is there, at that you should get peak amplitude for the output such that we feel that signal is detected. That is the reason first it is folded, later on it is shifted in matched filter. When you convolve two equal length rectangles, every one of us know it is a triangular function. Every one of us know it is a triangular function. Why first folding, later on shifting means at the delayed instant, we should get peak value in the output. at the delayed instant. Every aircraft system will have this provision because the aircraft systems are controlled by ground station. Whatever the ground station signal that is sent, pilot has to receive the same signal. Otherwise, they will deviate from the path. Some mishap may happen. Another important thing is generally musicians will copy music from English musicians or any foreigners. Most of Bollywood or Tollywood, anyone, they will copy the music. From where they have copied the music, that can be easily detected by using a correlator. By using a correlator, we can easily detect from where that original song was copied. Okay. They will say for that a word inspiration. Okay. There is another concept called as hidden periodicity. This is also maintained by musical instruments. Hidden periodicity is maintained by musical instruments. After what time exactly the pattern repetition occurs? After exactly what time the same music pattern repetition occurs? That also we can check by correlation. Means when you are listening to a particular song, sir, whatever the initial 30 seconds or 40 seconds music pattern is there, somewhere in the middle of the song it is repeated. That we can check by using, not by our watch, by using a correlogram. Correlogram is the device that will find out the autocorrelation or cross correlation of a given signal. Correlogram. Correlogram is the device. See, I have given an example here. A signal is transmitted. Suppose aircraft system has to detect the signal. The receiver is sending the signal with a noisy version. With a noisy version. From the noisy version, how to detect our original signal is there or not. It will transmit a signal, reverted back. It is echo, reverted back. So the answer to this problem is correlation. The answer to this problem is correlation. A signal x of t is transmitted in reverse with amplitude scaling. It is reverted back. How you can say whether our original signal is correctly received or not from a distant target, that we are measuring by using the concept of correlation. Another easy way of understanding correlation, let me explain. Everyone see here. Correlation is always function of the amount of delay, sir. Correlation is always function of the amount of delay. Assume we have transmitted a sine wave of small burst. In the channel, suppose it is at this location. X of t minus 2, they are no way correlated, means 0. Suppose the same signal has appeared here. Still they have not correlated 0. Suppose the same signal have appeared here. Some part of this one, some part of this one has correlated. Suppose that shifted signal has came to the same position of xt, means it is 100% correlated. So autocorrelation is a function of amount of delay. It is a function of amount of how much the original signal is deviated from its shifted version. For measuring that, we are using which concept? Correlation. It will tell us the measure of similarity between two different signals. So what is the basic difference between convolution and correlation is, in convolution we followed 4-step procedure: folding, shifting, multiplication, integration. Without folding operation, convolution is treated as correlation. Without folding operation, convolution is treated as correlation. Because you are comparing xt with x of t minus 2, here also you are comparing xt with y of t minus 2. Without folding, convolution is treated as correlation. Without folding. What are the mathematical relations we require to find the correlation is, observe here. So autocorrelation function can be defined for energy signal as well as power signal. For energy signal, what is the formula? Integral x of t into x of t minus 2 dt, or x of t plus 2 into xt dt. Why t minus 2 and t plus 2 means it depends on whether it is a real-time operation or non-real-time operation. It depends on whether it is lead or lag. Based on that, it can be selected as t minus 2 correct, sir. T plus 2 also correct. Power signal means every one of us know time average concept or not, 1 by 2t. So before finding the autocorrelation function, what is the first point you have to check? Whether the considered signal is energy signal or power signal. Without by hearting, what is the easy way of remembering the definition of correlation without by hearting? Everyone tell me, energy in a signal x of t definition is what for us? Integral mod xt whole square dt. It means x of t into x star t. If the signal is complex, we are writing xt into x star t, sir. Now, instead of xt into xt, what we have written in the formula, sir? Instead of xt into xt, what we have written? Xt into x of t minus tau. You remember energy definition? What definition you got? Autocorrelation. If the considered signal is complex, you can place conjugate also xt into x star of t minus tau. If the considered signal is complex. For real signal, maybe I have given the formula. If the considered signal is complex, you can place conjugate. Instead of xt into x star t, what we can write? Xt into x star of t minus tau. Power signal, time average. It means before finding autocorrelation or cross correlation of any signal, what is the first point you have to check? Whether the considered signal is an energy signal or power signal. Whether the considered signal is an energy signal or this we discussed in introduction chapter only, energy power signals. Looking at the graph only we can respond. Looking at the graph. How to remember this formula in easy manner without by hearting, sir? Energy definition you see, sir, everyone. This you know in time domain. Integral mod xt square dt, which means xt into x star t. Instead of xt into xt, what you have written? Xt into x of t minus tau. Conjugate for complex signal. Conjugate for complex signal. What are the different properties of autocorrelation function? What are the properties that are there for autocorrelation function is, one property, it is even function of tau. Rx tau equals to Rx of minus tau. Second property is autocorrelation at origin indicates energy or power in the signal. That is not a big deal. See the cursor. If you substitute tau place 0 here or here, sir. If you substitute tau place 0 here or here, 100% it becomes energy definition or power definition or not. 100% it becomes energy or power. Third point is maximum value of autocorrelation occurs at origin. Mod Rx tau less than or equals to mod Rx 0 for all tau. You select any instant of time, compulsory maximum amplitude is there at origin only. You select any instant of time, compulsory maximum amplitude will be there only at origin. Mod Rx tau less than or equals to mod Rx 0. Autocorrelation is always function of the searching parameter or lag parameter. It is called as searching or lag parameter. It depends on the amount of delay. In convolution, answer is obtained in terms of same independent variable x of t, h of t, y of t. But here you are taking xt, answer is retained in terms of tau. You are taking xt, answer is retained in terms of tau, sir, Rx tau. Autocorrelation is always function of the amount of delay. First three properties we will check from examples, how they are correct from the examples. What is the fourth property mentioned is autocorrelation in terms of convolution we have written as x tau convolved x minus tau. Autocorrelation in terms of convolution is x tau convolved x of minus tau. Let us verify how it is true. X tau convolved x minus tau, how it is true. Everyone recollect the convolution definition. How we have written general convolution formula? Integral of x of tau h of t minus tau d tau. To get answer in terms of t, we have chosen another variable as tau or not, sir? To get answer in terms of t. Now we want x of tau convolved x of minus tau. Let us take other variable as t. X of t, x of minus of tau minus t dt. See the notational changes I have done. Instead of tau, tau place I use t. After simplification, this is looking like our definition or not. What is the definition? Xt into x of t minus tau dt. We got similar way or not? Xt into x of. So autocorrelation in terms of convolution means what we can write? Signal convolved by folded version. Signal convolved by folded version. This is the fourth property. Autocorrelation in terms of convolution is signal convolved by folded version. X tau convolved X of minus tau. That is the fourth property, sir. What is the fifth property? Fourier transform of autocorrelation function is known as energy spectral density or power spectral density. What is the spectral density meaning? According to yesterday's discussion, magnitude whole square, Fourier transform whole square is called as spectral density or not? Fourier transform whole square. Let me explain this point. How you are saying autocorrelation Fourier transform is called as spectral density. Spectral density magnitude whole square. Listen everyone. What is the inverse Fourier definition? We know, sir. Inverse Fourier formula 1 over 2 pi integral of x omega e power j omega t d omega. 1 over 2 pi integral of x omega e power j omega t. If I conjugate this x star t, x star omega exponential becomes negative r. In the definition, if I take conjugation, x star t becomes 1 over 2 pi integral x star omega e power minus j omega t. Listen. What is the ACF of a signal, energy signal definition we have taken? Rx of tau equals to integral of x of t into x star of t minus tau dt. X of t multiplied by x star of. What is x star of t minus tau? This expression, you feel this like equation 1. X star of t minus tau means exponential t place t minus tau we are substituting. X star of t minus tau means t place. So it becomes integral of x of t 1 over 2 pi integral minus infinity to infinity x star omega e power minus j omega t minus tau d omega dt. Nothing I have done, only substitution of x star t formula here. Since from equation 1, since directly I have substituted that formula, sir. Here one integral is function of which variable? T. Another integral is function of which variable? Omega. Just rearrange these terms. 1 over 2 pi omega equals to minus infinity to plus infinity x star omega t equals to minus infinity to infinity xt e power minus j omega t dt. Still you are left with e power j omega tau d omega. Still you are left with e power. What is this? Everyone tell me. Xt integral xt e power minus j omega t dt is what, sir? X omega or not? X omega into x star omega is what? Mod x omega whole square. Mod x omega. So autocorrelation function is Fourier transform pair with spectral density. This is conveniently denoted as Sx of omega. This is conveniently denoted as Sx of omega. What I missed here? Exponential term. E power j omega tau d omega. That is also there. I am writing the next step which I want to tell. This is x omega, sir. X omega into x star omega is mod x omega square multiplied by. So autocorrelation Fourier transform pair with spectral density. What happens if I substitute Rx 0, tau plus 0? If I substitute tau plus 0, exponential becomes 1. It is nothing but our Parseval's theorem or not. Everyone recollect. Rx 0 meaning is autocorrelation function at origin is energy or power from our previous slide. Autocorrelation function at origin is energy or power in the signal. Right side area under spectral density. Sx of omega is spectral density. Area under spectral density denotes energy or power in the signal. So autocorrelation Fourier transform is called as spectral density. Autocorrelation Fourier transform is called as spectral density. Okay. The last observation here is, what is the relation between input and output spectral density? That is the sixth property, sir. Everyone see here. Neatly I have given. Y omega equals to x omega into h omega. If I take magnitude whole square, mod x omega whole square into mod h omega whole square. Mod y omega whole square is called as output spectral density. Mod x omega whole square is called as input spectral density multiplied by squared amplitude spectrum. Output spectral density is input spectral density multiplied by squared magnitude spectrum. Funny thing is, in our competitive exams, certain times without asking examples, sir, they will ask the properties only. Which of the following properties are correct for autocorrelation function? As multiple selective questions are introduced this year, they may ask which of the following four out of the four given options which may be correct by giving 3 statements correctly and 1 statement wrongly. You must be thorough with all these properties. This slide I proved for energy signals. Just a minute. Why it is jumbling? Silly fellow. This particular slide I proved for energy signals. For power signals, there is a separate formula that I will use directly in the problem. For power signals also there is a formula. Okay, you must be thorough with properties. One property is autocorrelation is even function of tau. Second property, autocorrelation at origin is energy or power in the signals are. Third property, maximum value occurs at origin. Fourth property, how autocorrelation is expressed in terms of convolution is signal convolved by folded version. Autocorrelation function Fourier transform is called as spectral density, energy spectral density or power spectral density. Last point is what is the relation between input and output spectral density means output spectral density is input spectral density multiplied by squared magnitude spectrum. In this derivation, what is the point we observed? Rx0 stands for energy or power in the signal. Sx of omega stands for energy spectral density or power spectral density. Area under spectral density again corresponds to energy or power in the signal. Okay. It is very easy to remember, no need to by heart. First I will discuss general method, mathematical tricks, solve problems in correlation. You observe carefully. First I will discuss general based on formula and mathematical tricks also. Listen carefully. Everyone first go through the properties. Everyone first go through the properties, sir. Near our home, some background noise started. As I am discussing correlation, they are using their own correlators, bachas. The easy way to remember the definition is what? Compare with energy definition, it becomes very easy for you. Energy definition integral mod xt square means xt into x star t, but autocorrelation, what is the change? Instead of xt into xt, xt into x of t minus tau. Only if the signal is complex conjugation. Otherwise, directly we can solve. Only if the signal is okay. The first example I am asking is, what is the autocorrelation function of the signal? 6 cos of 6 pi t plus pi by 3. I want what is the autocorrelation function of this signal 6 cos of 6 pi t plus pi by 3. Everyone tell me, is it an energy signal or power signal? Is it an energy signal or power signal? Just a minute. Why this came? Yes, sir. Everyone should respond. The considered example is an energy signal or power signal. The considered example is energy signal or power signal. It is cutting still. Okay. Now, sir, I think it is visible for everyone. Some of you said, as I have done zoom in, is gone. Very good. It is a power signal. It is a power signal. Good. Sinusoid. Sinusoid means power signal only. Good. What is the definition we have to use? Power signal means with average or not. See here, left side, everyone, see the cursor. Rx tau equals to limit t tends to infinity 1 by 2t integral minus t to t, like that. Come on. So our definition is limit t tends to infinity 1 by 2t integral minus t to t. What we are substituting inside the expressions are signal multiplied by shifted version xt into x of t minus tau dt. This is xt. This is x of t minus tau dt. xt into x of t minus tau. That we have to simplify. That we have to simplify. Time averaged autocorrelation function. Next, our enjoyment is simplification, sir. Here 6 6 are 36. Take 18 separately. Take 18 separately. 6 6 are 36. 18 separately. Such that we can adjust 2 cos A cos B. What is 2 cos A cos B? Cos A plus B. Cos A plus B one term. Another term cos A minus B. Internally adjust 2 cos A cos B rules are here. Cos A plus B one term, cos A minus B is other term. Okay. But first integral gone. Why? Cos is function of t, integration is done with respect to t. Normally, cos for one cycle the area is 0, but in this example it is happening for infinite cycles or not. Cos for one cycle area 0, but here it is happening for infinite cycle. So first term is gone. Second term cos is function of tau, integration is done with respect to t. Second term cos is function of tau, integration done with respect to t. Take it separately. Cos is independent of t, second term. So minus t to t dt, cos of 6 pi tau, take it separately. It is independent of t. This integral is simplified as 2t or not? 2t cancellation. What is the new answer? 2t cancellation. What is the new answer, sir? 18 cos 6 pi tau. 18 cos 6 pi tau. Here 2 cos A cos B adjustment. Cos A plus B plus cos A minus B. 6 into 6 is 36. I have taken 18 such that 2 cos A cos B adjustment. First time cos is function of t, integration is done with respect to t, gone. Second term cos is function of tau, which is independent of t. This integral simplified as 2t. 2t cancellation, answer 18 cos 6 pi tau. 18 cos. Now you can check all properties. When you draw this function, the first property we said here is autocorrelation is an even function of tau. Satisfied or not, sir? Cos minus theta becomes cos theta. Autocorrelation is even function of tau. First property. Second property we said is autocorrelation at origin is energy or power in the signal. Autocorrelation at origin. As it is power signal, cos 0 becomes 1, 18 units. Cos 0 becomes 1, 18 units. Maximum value of autocorrelation occurs at origin, that is 18. It may be at any other tau, but compulsory maximum will be there at origin. All properties are satisfied. All properties are satisfied. For power signals, we will take for one cycle, and that is the reason time average limit t tends to infinity 1 by 2t. When you are finding the period also, power of a periodic signal 1 by t integral mod xt square dt. Even the signal is infinite length. All properties are satisfied. Even function of tau satisfied. Autocorrelation at origin, power in the signal satisfied. Normally, what is the power in the sinusoid? 6 square by 2, 18. Satisfied. Maximum value of autocorrelation occurs at origin, that is also satisfied. But this is, I don't like, time domain method. Okay, lengthy. What is frequency domain method of solving this is alternative technique. Power spectral density of periodic signals is given by this relation. 2 pi into sigma minus infinity to infinity mod Cn square del of omega minus n omega naught. Power spectral density. How we got this formula means, this derivation I have done for energy signal, sir. For power signal, what you have to do is, periodic signal means Fourier series or not. X of t place we should substitute sigma Cn e power j theta. X star of t minus tau means Cn star e power. That mathematical enjoyment you have to do. Okay, after doing that enjoyment, whatever the formula I have given here, that you will get, which I have not done. Directly I am taking. For a periodic signal, we can write Fourier series. What is Fourier series form? Every one of you know. Sigma Cn e power j omega naught t. Star means Cn star e power. By that way, we can solve. After doing the derivation, this answer you will get. Everyone see, what is x of t considered in the example, sir? 6 cos of 6 pi t plus pi by 3. Only single harmonic is there. Every one of you know the Fourier series standard form is sigma Cn e power j n omega naught t. Listen the logic. Sigma Cn e power. How I can write this in terms of exponential form, sir? Cos theta is e power j theta plus e power minus j theta by 2 means 3 e power j pi by 3 e power j 6 pi t one component, 3 e power minus j pi by 3 e power minus j 6 pi t another component, y3 by 2 6 by 2 expand. So what is a Fourier series spectrum I can take here? Cn versus n omega naught. We have only single frequency. Omega naught is 6 pi, single frequency. Yeah. Positive harmonic, negative harmonic. Only two frequencies are there. Positive harmonic plus 6 pi minus 6 pi. N is multiple of 6 pi, sir. Positive harmonic, what is the amplitude? 3 e power j pi by 3. Negative harmonic, what is the amplitude? 3 e power minus. Find the Fourier series coefficient of this one we obtained. I hope you have remembered Fourier series expansion. Cos theta is e power j theta plus e power minus j theta by 2. That way. Okay. For positive harmonic and a negative harmonic, take the amplitude. Anyway, in our problem, we want mod Cn square r. What is magnitude of both impulses? 3 whole square plus 3 whole square modulus. 3 whole square plus. So from Cn spectrum, from the Fourier series spectrum, what is Sx of omega? Answer I can write, sir. 2 pi into mod Cn square means 3 whole square del of omega minus 6 pi one term. This negative side frequency also 3 whole square into del of omega plus 6 pi is another term. That is nothing but 18 pi into del of omega minus 6 pi plus del of omega plus 6 pi. What is the inverse Fourier transform of pi into two shifted impulses? What is the inverse Fourier of this quantities are pi into 2 shifted impulses? Cos function or not? Answer is 18 cos 6 pi tau. Answer is 18 cos 6 pi. First you write Fourier series form of 6 cos of 6 pi t plus pi by 3, which is this Fourier series spectrum. But we want modulus of Cn square for the considered frequencies. Magnitude of them is modulus of this quantity becomes here 3s are whole square. Whatever the frequencies that are taken, take them also. Omega plus 6 pi, omega minus 6 pi. This is looking like Fourier transform of which function? Cos function. Answer is obtained easily. So time domain overaction is integration. Time domain we have to do integration. Frequency domain it is easy only when you are thorough with this relation. Frequency domain it is easy only when you are thorough with the relation. Why the first cos term 0 in the previous slide is cos function of t integration is done with respect to t. General area under cos for one cycle is 0. But in our example it is happening for infinite length. T tends to infinity means infinite cycles it is happening. Gone. Second cos is function of tau. It is independent of t, sir. Second cos term is function of tau independent of t. Power spectral density of periodic signals. With this logic, we are answering the same question in easy manner. With this logic, power spectral density of periodic signals. How we got this formula? Here I have done one derivation or not. How autocorrelation Fourier transform spectral density. So like that you take autocorrelation of power signal 1 by 2t integral xt into, in the place of xt you substitute this Fourier series form. Do that mathematics. Simplification if you do, that will create this answer. 2 pi into sigma mod Cn square del of omega minus n omega. Those who don't want to solve this problem at all, for that lazy fellows, easy way to remember the answer is, whenever you take a cos or a sin omega naught t plus theta, the fixed autocorrelation is a square by 2 cos omega naught tau. It will never change. Whenever you take a cos or a sin, whenever you take a cos function or a sin function, fixed autocorrelation is a square by 2 cos. See this 6 cos of 6 pi t plus pi by 3 means what is the answer? 6 square by 2 cos 6 pi 2 or not? 6 square by 2 cos 6 pi. Those who doesn't want to solve the problem, for that fellows, this enjoyment directly. A cos omega naught t plus theta or a sin omega naught t plus theta. That becomes a square by 2 Why not sign in last step? Are bacha 5 into 2 shifted impulse is Fourier transform of cos middle minus is there means you may think about sin. 5 into 2 shifted impulses is spectrum of which function? Cos function. Whenever you take a cos or a sin, autocorrelation is a square by 2 cos omega naught tau. Okay. For all periodic signal, either autocorrelation or cross correlation, you can solve by Fourier series logic. I am discussing some more examples. Don't be tensed up. This is the first model we solved. Some more examples are there. With Fourier series logic only we can solve. No need of stupid integration like this first one. No need. Whenever you take a cos or a sin function, the fixed autocorrelation function is what means? A square by 2 cos omega naught tau. Now everyone tell me what is the autocorrelation function of a constant signal A? Constant I have given A. Is it energy signal or power signal? Is it an energy signal or power signal? Come on, friends. Constant for all time. Is it energy signal or power signal? Signal which maintains constant amplitude or infinite time is power signal. According to our definition, Rx tau equals to limit t tends to infinity 1 by 2t integral minus t to t time average. Power signal linked to time average formula or not? Power signal. Signal is A, shifted version is also A. X of t is A, shifted version is also A. Answer is A square 2t jump. A square or not? So autocorrelation function of a constant signal A. Answer is what? A square. Simply A square. Good. Based on this, one funny question was asked in one of the exams, sir. Power spectral density of a signal x of t is 8 pi del omega. Power spectral density of a signal x of t is 8 pi del omega. He wants the signal. Find x of t. Power spectral density of a signal is 8 pi into del omega. Get the signal. Think and answer me. We want x of t answer. Hint is neatly available for your previous example only. Impulse in frequency domain means what will happen in time domain? 1 Fourier transform we know as 2 pi del omega r naught. That fellow has given now spectral density for us. What is that quantity? 8 pi into del omega, which can be written as 4 into 2 pi del omega. So the inverse Fourier transform of spectral density is what, sir? Autocorrelation function. Inverse Fourier transform of spectral density is autocorrelation function, that is 4. Bracket term 1, sir. 4 can be written as 2 square or not. For a square form. So what is the signal answer? Just 2. Don't take 4 gone. I have asked to find the signal, not find the autocorrelation function. Find the signal. Answer 2. Very good. What is the cross correlation function of x of t equals to e power minus j 10 pi t and y of t equals to cos of 10 pi t? Cross correlation, now I am asking, not auto. Auto means same signal. What is the cross correlation function of a complex sinusoid and a normal sinusoid? Of course, cosinusoid. Both are periodic functions. Previously, for autocorrelation, I used one logic, 2 pi mod square logic, mod cn square logic. Now, I'll give hint for you. Assume xt Fourier series coefficient is Cn. Both are periodic functions, are complex sinusoid as well as sinusoid. Yt Fourier series coefficient is Rxy tau. Cross correlation function of xt and yt means Rxy tau has Fourier series of Cn star Dn, as one of the signal is complex Cn star Dn. You find out Fourier series coefficient of this one and this one, multiply them, directly you can write the answer. Every one of us know what is the Fourier series style. Sigma Cn e power jn omega naught t. Sigma Cn e power jn omega naught t. Come on. Have a thought. Both are periodic functions. Find out Fourier series coefficient of xt and yt. They have same frequency 10 pi. Otherwise, how they will be correlated? If one frequency 10 pi, another frequency 12 pi, they don't have any common thing. Think and answer me. For x of t, the common harmonic is 10 pi. They have frequency of 10 pi or not. For x of t, what is n omega naught logic? In comparison with Fourier series, it has negative harmonic or positive harmonic? Negative harmonic. At -1 it is there with coefficient 1. Nothing is there means 1 or not here. You see, sir. 1 into e power minus j 10 pi. N is -1. N into 10 pi means minus 10 pi. Whereas for y of t, what is the Fourier series spectrum we can draw? n into omega naught logic. Cos expansion contains e power j 10 pi t plus e power minus j 10 pi t by 2. So cos expansion contains which frequencies? Both. It contains both positive and negative harmonics. Again, they are multiple of 10 pi. I am not writing 10 pi, lengthy. Only harmonic number I am writing. So this is like Cn for you. This is like Dn. That is our assumption. Xt coefficient Cn, Yt coefficient. For the R xy of tau, for getting the cross correlation, we require which product? Cn star into Dn. Already Cn is a real number. Everyone see here. Suppose Cn is j here. You should take minus j here. Be careful, sir. Luckily, this impulse has real amplitude number. If I multiply them, both of them, which frequency I can retain? If I multiply both of them, I am retaining only which frequency? Negative frequency or not? With amplitude how much? 1 by directly, what is the answer I can write, sir? It has retained 1 by 2 e power minus j 10 pi tau. It has retained coefficient of 1 by 2, which has negative frequency e power minus j. Any integration I have done, time waste. No need to do any integration. Everyone see here one more time. A complex sinusoid and real signal, I want cross correlation function. I assumed xt Fourier series coefficient as Cn, Yt Fourier series coefficient as Dn, sir. Xt signal coefficient Cn, Yt coefficient Dn. The cross correlation function of xt, Yt Fourier series spectrum is Cn star Dn. By using Fourier series expansion, I have drawn Fourier series spectrum of both the signals. This signal contains only negative frequency. Y of t signal contains both positive and negative frequency. Cn star is also 1 star is 1 only because it is a real number. After multiplication, this is 1 by 2. Both coefficients are 1 by 2 or not? For cos functions are both coefficients are. After multiplication, I am left with this. I have retained only negative frequency which corresponds to that exponential term. Suppose if you don't want to follow this method, see what is the enjoyment you should do. Rxy tau equals to limit t tends to infinity 1 by 2t integral minus t to t. X of t means e power minus 10 pi t. Y of t minus tau means cos 10 pi into t minus tau dt. This stupid integral you should solve. That will show this answer. When you will get tomorrow morning, x of t into y of t minus tau dt. After simplification, first you solve that enjoyment, you will know. Time waste. Stupid technique. Stupid technique. Whenever you take a periodic signal, we have a predefined Fourier series coefficient or not for periodic signal. Directly use the logic. Directly use the logic. For periodic signal, find out the Fourier series spectrum of both the functions. They are like this. Find out the Fourier series spectrum of both the functions. After that, what is the cross correlation function? Fourier series spectrums are Cn star into Dn. Cn star means this is a real number 1. 1 star is 1 only. So 1 into 1 by 2 becomes 1 by 2. It has retained only that negative frequency. Actual method is solving this stupid expression to get this answer. Time waste. Unnecessary time waste. Okay. Arey bacha, this is also a periodic function which can be written in Fourier series. Cn comes only with xt. Cos expand karo, wo bhi exponential hai na. Right? For the signal y of t also we have Fourier series coefficient with the positive plus 10 pi minus 10 pi harmonics. If both frequencies are different, how they are correlated, bacha? What is the stupid question? Idhar dekho, cos 2 pi t means n into omega naught logic plus or minus 1 Suppose I have given cos 6 pi t. Again, if you want to go by same logic, 3 and minus 3, n into 2 pi logic. Where you have, they are orthogonal to each other. Only when they have same frequency, that chance is there, brother. Only then when they have same frequency. If they have different frequency, they will be automatically orthogonal. Minimum 2-3 problems you will solve. You solve on this, it becomes easy only. My job is discussing method, whichever you like, you enjoy, because you are writing the exam. Instead of solving the integral, I feel finding the Fourier series spectrum becomes easy. It is not a rule that you should take xt with yt only. Suppose you want to find yx tau. Then how you should take Fourier series spectrums are dn star into cn. Yeah, for xt I started means cn star dn. If I start y with respect to x, then you have to take dn star into cn. dn star into cn. Everyone see here. What is the relation between them? Rxy tau and Ryx tau is, if both are real signals, Rxy tau answer must be equals to Ryx of minus tau, if both are real signals. If one of the signal is complex or both are complex, Rxy tau is Ryx conjugate of minus tau. If the considered signals are real signals, Rxy tau is Ryx minus tau. If one of the signal is complex, which condition you have to hold? Ryx conjugate of minus tau. Here one signal complex or not. So if you solve by this method, you should hold which condition? Rxy tau must be equals to Ryx star of minus tau. Then only you can feel your answer is correct. Then only you can feel your answer is correct. Real signals directly Rxy tau is Ryx of minus tau. Complex signals conjugation is needed. Complex signal conjugation is, if you take x with y, cn star into dn star, y with x, dn star into cn, dn star into. Till now we solved some examples on power signals. 2-3 models I solved. Okay. If my question is, what is the autocorrelation function of decaying exponential? Respond everyone. Is it an energy signal or power signal? Decaying exponential I have given energy or power. How you can find C and Dn without integrating? Arey bacha, kaise bache? Cos 10 pi t expand karo. Compare with Fourier series. G power j 10 pi t n omega naught is 10 pi sir. वहाँ पे कितना coefficient है? Cn 1/2. Directly you can take. Coefficient directly ले सकते हैं. This can be expressed in terms of Fourier series. No need of integration. That is the beauty of sinusoids, na? Once you convert cos or sin in terms of exponential, directly you can take Fourier series spectrum. No need of integration. Because we are using frequency domain concept here, not time domain. Decaying is energy or power? Excellent. Energy signal. Energy signal means with average or without average. It is an energy signal. We should solve with average or without average. Yes. Autocorrelation function of energy signal means without average. Integral xt into x of t minus tau dt. Integral xt into x of t minus tau dt. Without average. As the considered signal is real signal, I am not taking conjugation. This is a real signal. I am not taking conjugation. Xt into x of t minus tau dt. Simplify and tell me. It is energy signal, correct? I want the autocorrelation function answer. This is our stupid definition. As the considered signal is real, I have not placed conjugation there, sir. Integral xt into x of t minus tau dt. If you substitute in this definition e power minus 3t ut e power minus 3 into t minus tau u of t minus tau dt. Integral xt into x of t minus tau means this one. How to solve this integral? There are two cases. You have to simplify this integral, not according to your convenience. T greater than tau one possibility, t less than tau another possibility. Tau may be lead or lag. It is not in your hands. Whether it is real time or non-real time, you don't know. T greater than tau, limits of integration will change. T less than tau. How to decide that? That is decided by ut into u of t minus tau. It means solving this way is lengthy. Those who want to solve, enjoy at home. Time waste. What is alternative? How we express the autocorrelation in terms of convolution? Our fourth property is what, sir? How we express the autocorrelation in terms of convolution? Signal convolved by folded version. Where is that slide? Yes. Fourth property. Signal convolved by folded version or not? X tau convolved x of. Listen first. E power minus 3 tau u tau convolved with e power 3 tau u of minus tau. E power minus 3 tau u tau convolved with e power 3 tau u of. What is the Fourier transform of this expression? Everyone recollect the formula. Autocorrelation Fourier transform, spectral density, decaying exponential means what is the answer? 1 by a plus j omega. Increasing exponential, what is the answer? 1 by a minus. Answer becomes simply omega square plus 9. Denominator omega square plus 9 is there, means omega square plus a square. Numerator what you want? 2a. 2a by a square plus omega square is Fourier transform of which function, sir? 2a by a square plus omega square is Fourier transform of which function? Two-sided. 1 by 6 e power minus 3 mod tau. 2a by a square plus omega square is 1 by 6 e power minus 3. All properties are obeyed. Autocorrelation has maximum amplitude at origin, even function of tau. Autocorrelation at origin is energy in the signal, that is 1 by 6. If you solve energy in the signal directly also 1 by 6 only. What is the disadvantage of solving this problem from time domain? Two different cases we should answer that ut into u of t minus tau, t greater than tau, one limits are, t less than tau, another limits, then we should combine the answer. Again tomorrow morning. Easy method is what? As we know spectrum of both the functions, easily we got the result of decaying exponential 1 by a plus j omega, increasing 1 by product is omega square plus a square, numerator 2a adjustment, we got the answer. विदाउट एवरेज, अरे बच्चा ये तो एनर्जी सिग्नल है, कैसे एवरेज रहता? ड्राउजी फेलो. Only for power signals we require 1 by 2t tags, sir. This is energy signal, sir. देखो decaying exponential energy. Why we require average? Oh, build up without बोल के. Good. Some of you have answered 1 by 6 e power minus 3 mod tau. So what I have done, power signals I avoided integration. Energy signals also I want to avoid integration. Means being thorough with properties. Every day I am saying this point only with you. Unless otherwise you are not thorough with properties in signals, nothing you can do. But you need practice. Don't be tensed, sir. I am also not very much thorough in a single day. By practicing only, I got all these techniques. If you practice my classroom notes at least 2 or 3 times, you will be masters in the subject. But you have to practice. Overaction, you will not get anything. Go on doing integration in GATE exam means 2021 becomes 2022. Simplified technique. Without integration only we got the answer. Without wasting our time. Tell me. Follow this method. When you want to find out the autocorrelation function of energy signal, what is a simple technique? Signal convolved by folded version. I will ask another question. What is there, bacha? Suppose I want what is the autocorrelation function of sync pulse. For sync, I am asking autocorrelation. Sync function energy or power? Sync pulse energy. Sync pulse is energy. Folded version of sync is again sync. Sync convolved by sync is what? Sync only. Sync pulse convolved by sync pulse is what again? Sync. Energy signals, this is easy method. Energy signals using properties, easy method. Okay. I will ask another simple model. Let me see how many of you will give correct answer for me. What is the cross correlation function of e power minus t square and e power minus 2t square? Both Gaussian functions I have given. Final answer must be Gaussian only. Gaussian convolved by Gaussian is Gaussian, that we know. But now I am asking cross correlation function. So CCF of x of t and h of t, if I represent that as Rx h tau, sir, what I mentioned with you just now, using property is easier. I can write that as what? X of tau convolved h minus tau. X of tau convolved h minus tau. Both are energy signals. Don't be tensed. Gaussian functions, they are energy signals. Think and answer me. E power minus 3t square. No, ma? No. Previous example, what I have done, after taking the property Fourier transform, then I obtained inverse Fourier. I'll give that formula also. What is the general formula we derived? E power minus at square. Fourier transform we have defined as what? Root of pi by a e power minus pi square f square by a. So you take Fourier transform of both functions, then you may get. It is not easy, try. Time is not over. Maybe आपका दिमाग हो गया आज. सॉल्व करो, सॉल्व करके जाओ. You follow your own method. I am giving 2 minutes time. E power minus 3t square is wrong answer. Other than that, you can try. Suppose if I take Fourier transform here, everyone see. Yes, xh of f is x of f into time reversal property h minus f. X of f into h. Let me write separately the spectrums. E power minus t square Fourier transform is what according to the given expression for me? Root pi e power minus pi square. A number 1 or not, sir? E power minus 2t square Fourier transform is what? Root pi by 2 e power minus pi square f square by 2. Individual signals spectrums I have written. This is like xf. This is like hf. This is cross correlation function. This quantity is called as cross spectral density. Cross correlation function Fourier transform is cross spectral. Even if I substitute f place minus f, answer is same or not, sir? Just multiply them. Root pi e power minus pi square f square into root pi by 2 e power minus pi square f square by, anyway, pi by root 2 e power minus 3 by 2 pi square f square is the spectral density. Just multiply both the spectrum. H of minus f also same, sir. H of. This answer must be adjusted like this formula. See everyone, see the cursor. This answer must be adjusted like this formula. See everyone what I am doing. E power minus pi square f square by a. 2 by 3 I am writing because it is 3 by 2. Still what you want extra? Root of pi by 2 by 3 we want. Root of pi by means root of 2 by 3. Simple adjustment. Whatever the adjustment root pi by a style you want, that adjustment you do. Okay. Root 2 jump. So overall answer becomes what? Overall answer becomes what here? If I take inverse Fourier, r xh tau equals to some scaling factor is there. What is that scaling factor? Root pi by 3. This quantity corresponds to e power minus at square. What is it? Is a number, sir? 2 by 3 t square. A number is 2 by 3. I have adjusted this like spectrum formula minus pi square f square by a. 3 by 2 term I have written as 2 by 3. Normal form 3 by 2 again. Correct or not? So this is the answer. For the first time, I have solved this model only to tell you energy signals. Which one is good using the convolution property. Signal convolved by folded version. Signal convolved by folded version. Today night, after having dinner, sit and solve this problem by normal integration method. Whether you are getting this answer or not, you cross check. Then you will know the beauty of the method. Okay, wantedly I selected this problem. Slightly tough, sir, because the background is this formula. Slightly tough. Don't be tensed. Some mathematical adjustments are needed. Okay, slightly tough problem only I have chosen. Still, this topic is not over. Don't be tensed. My emotion from last 1 hour is, if a periodic signal is given that becomes power signal, solve the autocorrelation or cross correlation with which logic? Fourier series coefficient logic. Fourier series coefficient logic. If energy signals are given, solve autocorrelation or cross correlation with which logic? Signal convolved by folded version logic. Signal convolved by other signal folded version. Previous example I explained autocorrelation function of decaying. Signal convolved by folded version. This example what I have explained? Cross correlation. You do one thing, this problem only you solve this on your own. If I want h with respect to x, then we should take h tau convolved x minus 2 or not, sir? H tau convolved x of minus 2. This you try at least. Then you can cross check your result are correct or not. Here I should not write t because I have represented that as tau. Tau square, sir. Tau square. Okay. We'll discuss some more models tomorrow's class related to this topic. That's all for today. Enjoy. Tomorrow we'll meet again. Okay. Those who have doubts, stay back. Yes.
Hello, sir.
Hmm.
Sir, I have a doubt in this complex envelope signal problem, sir.
What?
That we have considered a problem where we have took that sink as m of t, no, sir.
Hmm.
Why haven't we considered this complex envelope Hilbert transform, sir, for this problem?
Why have not considered means m of t sign? Just now I discussed in under Hilbert transform. M of t cos Hilbert transform. What we have written now? This xt cos means xt sin. It is not affecting xt now because it is a band limit.
Okay, okay. As it is band limited, we are not considering it.
Yes, sin pi t by 5 band limited signal.
Okay, sir. That's it, sir. Thank you, sir.
Yes. Yes.
Sir, 12F slide.
12F.
Yes, sir. In the third case,
Ah.
sir, there should not be amplitude distortion, no, sir.
Who said amplitude must be everywhere k, not according to our convenience, certain range 1, certain range 2. Everywhere it must be same multiplier k ma.
But sir,
See, listen.
yes,
Here
sir.
1 input side, output side if you have 2, no problem. Both are scaled by same factor.
Okay.
This is not a distortionless system. Distortionless system means everywhere magnitude must be constant for all range of frequencies, not according to our convenience.
Okay. Sir, but that 220 frequency lies where magnitude of h of omega is 1.
This system is not a
No,
distortionless system.
Okay, sir. Thank you.
Yes.
Hello.
Yes.
So in page number 16F,
16, huh?
so there I understood that we are taking empty because it's band pass, right? If it's not a band pass signal, then
The job of complex envelope signal is it will convert low pass to band pass. This is modulator diagram. If our original signal is low pass, it will be converted to band pass. If this is band pass, mathematically it has converted finally the answer to low pass. Both ways it will do. Low pass to band pass it will do, band pass to low pass also it will do.
So also this MD is not affected that I understood in Hilbert transform.
Ah.
It's not affected, but how is it not
It is
affected?
not affected. M of t is not affected. Ma. There I have given example. M of t cos xt cos means xt sin directly we have written. With derivation also I have done there.
So, but that was in Hilbert transform. No? And this is
Array, what you are substituting here, ma? Hilbert transform only. What is the formula containing complex envelope formula contains which terms, ma? Signal plus j times Hilbert transform of the signal. Later on it is multiplied by complex sinusoid.
okay.
Uh,
In 18 is.
uh.
How did we get that output via the when this
Here I have taken an example as a rectangle. Matched filter in communication we are learning as folded and shifted version. Why folding is done means
to get the highest
in
energy.
the same signal here. To get the output at the delayed instance, we know what is the amount of delay that is caused. So at the delayed instant, if output contains the peak amplitude, immediately we can feel that signal is detected. For that purpose, first folding, later on shifting is done. Okay?
Not represented the whole steps, right? That's what these are not the whole steps, right? One more shifted version of XT will be there.
Add one more shifted. First we have done folding minus t to 0. That is right shifted by t means same graph. Na?
Thank you, sir. Thank you so much.
This signal is right shifted by t means h of t itself. Na?
Yes, yes. Good. Thank you.
Hello, sir.
Sir,
Generally, why do we study Fourier before Laplace, sir? Means Laplace is combination of real and imaginary.
subject name is what? Signals and system. First we'll analyze signal frequency components of the signal. Then we'll do system analysis.
Okay.
Huh?
Yes, that's it.
That is a doubt. Oh. Okay.
Hello, sir.
Bolo, sir.
Hello, sir. This correlation, can you explain once again, sir? I came late, sir.
Correlation means comparison. Whenever you are comparing the signal with its shifted version or another signal, one signal with another signal shifted version, that is called as correlation. Suppose we transmitted the signal graphs are 0 to 2. In the channel, we are checking whether the shifted version of the signal is same as the original signal or not, or do you have any deviation. So if this is the signal transmitted, this is the noisy version of the same signal. From the noisy signal, how to get the estimate of the signal means that is by using cross correlation function concept, where we are comparing the spectral densities. If the input and output spectral densities are matched at certain range of frequency, we feel that is signal information. Otherwise, it is noisy information. Like that, some applications I explained. Next, radar. Assume this is the pulse, some signal transmitted.
Okay.
Like that.
Okay. This I understood, sir.
Okay. Next.
Sir, last problem, sir.
What last problem? Gaussian. What happened?
There, h of minus f.
H of f minus f is hf only. Gaussian folded version is same thing. Na?
Okay, sir.
That is the reason as it is I said.
Okay, sir. In one more 25f, sir.
5.
Sir, here, if they give this type of problem, we need to convert in frequency only, sir.
No. My technique is like that here. If I solve in frequency domain without doing any integration, I got the answer. There is no need of wasting time. Any periodic signal is power signal. Periodic signal can be written in Fourier series or not. So I used that logic to solve problem easily.
Okay, sir. Okay, sir. Thank you, sir.
Right.
Hello, sir.
शर्मा बोलो जी.
Sir, I did not get the logic behind how to solve power signals, sir. Once.
Power signal means not every power signal. Step function is also power signal. Only for periodic signal.
Okay, periodic
For
signals.
periodic
We will
signal,
find.
this is periodic. This is periodic, na?
Okay, sir.
This is periodic. This is periodic.
Uh,
That too, they should contain same frequency. Suppose 5 pi, 10 pi also there. Here correlation is 0. They are
okay,
not
sir.
correlated. They must match to the same frequency. So any periodic signal, how to get autocorrelation or cross correlation means find the Fourier series coefficient, sir.
Okay, sir.
So I have expressed this in terms of Fourier series sigma Cn e power j omega naught t. So my first term corresponds to negative frequency minus 10 pi. I have drawn one impulse Cn. Fourier series spectrum we know how to draw.
Yes, sir.
Cross expand karo.
Okay,
1 by 2, 1 by 2. दोनों 1 by 2 है ना?
Okay, sir.
So cross correlation Fourier series spectrum is Cn star into Dn.
Okay.
But already Cn is a real number. Suppose this is j, we should make minus j.
Okay. Sir.
Okay,
Sir,
1 into
what if autocorrelation function? What is the form?
autocorrelation only Cn is sufficient ना?
Only
अरे
Cn.
बच्चा इधर mod Cn square बोले तो क्या है Cn into Cn star है ना?
Okay, okay, sir.
हाँ,
Thank you, sir.
right. हाँ. Yes.
Hello, sir.
Yes, ma.
Hello, sir. Am I audible?
Tell me.
So, for an LTI system, if the input and output are given, will the impulse response be unique, sir?
No.
For the same input and output, sir.
No, need not be. Because
Sir,
you take my example, sync T convolved sync T is sync T. Sync T
Yes, sir.
convolved sync 2T is also sync T.
yes, sir.
I have changed the system now. I have changed the frequency.
Okay. For sometimes it will be unique or
Sometimes it will be unique only, but generally it may change.
okay, sir. Thank you, sir. That's it.
Tell me, sir.
Sir, could you open 27F, sir?
1 minute.
Sir, here you told us to find RHX of that means x of minus tau. But here there will be no change. No,
Also you find out. Same technique. However, I solved reverse way you find out. To check that finally what relation you should hold RXH and RHX out of relation what you have to hold. This. See here. This cursor are you observing? If you hold this relation, your answer is correct. RXH tau must be equals to RHX minus tau for real signal. You try this on your own here. Already HF available, XF is available. HF into XF. Simplify karo.
No, sir. Means that I was not telling. Sir, I was telling it will be same only. No, sir. Means like no.
In this case, it may be same. Suppose one of the signal is complex, it may differ.
That only I was asking.
It may differ. It
Sir,
need
one,
not be same.
sir, 18F could you open, sir?
Which one? 18. क्या हो गया आपको? गया. Yes.
Sir, sir, in the one of the problem you told that m of t remains same. So it is band limited, na sir?
Band limited only.
I didn't understand.
Minus pi by 5 to pi by 5, na?
Sir?
It covers from minus pi by 5 to pi by 5 means band limited only, yeah.
Okay, sir. Okay, sir. That's my doubt, sir. Thank you, sir.
Over,
Over, sir. Over, sir.
enjoy. Yes, sir.
Hello.
Yes, sir. Yes, sir.
Good evening, sir. Sir, how cross correlation function Fourier series is Cn star into Dn star, sir?
The derivation. Autocorrelation, what I have written, mod Cn square meaning is what? Cn into Cn star, ne?
Yeah, that's for spectral density, sir.
This is also cross spectral density. Instead of power spectral density, it is called as cross spectral density. Cn star into Dn.
No. For what we have to do complex. For which one we have to make complex?
Suppose if our Cn, suppose I have given sine term here. Sine term का क्या होता? Fourier series coefficient 1 by 2j minus 1 by 2j होता ना? then you should take star of that one. 1 by 2j minus 1 by 2j Cn star bole to minus 1 by 2j plus 1 by 2j. Okay.
Okay, sir.
Today you do one thing. Take sine 10 pi t as one signal, cos 10 pi t as other signal. Sine 10 pi t one signal, cos 10 pi t other signal. By using our procedure, you try, then you will know why I have taken star.
Okay, sir. Sir, one more one. That low pass plus high pass you said no, sir, for Hilbert transform. All pass.
Low pass plus high pass. I have not used that word.
Hilbert transform. Hilbert transform magnitude is all pass filter.
Like all pass filter.
Yeah, for all pass filter energy is infinity, no, sir.
So what?
How
no
it is practically available?
No practical system needs infinite energy.
Okay. Okay. Thank you, sir.
Yes. Yes.
Hello, sir.
Sir.
Sir, yesterday you have discussed one problem under frequency differentiation, sir. Sir, I have a doubt in that problem, sir.
What is it?
Sir, it is actually it is ramp from -1 to 1, sir.
What
sir,
is your doubt? Tell me.
Sir, in the differentiation.
This one, tell me, what is your doubt?
Sir, my doubt, sir, while differentiating, like differentiation of UV, no, sir. UV dash plus VU dash, no, sir. Hello? Sir, there are two terms, no, sir.
Where?
Sir, it can be written as T into rect T by 2, no, sir.
That we have written.
Why of? Sir, if it, sir,
in T by d omega spectrum also we have written.
Sir, in the alternative method, you have differentiated it, sir.
अरे दोनों simplify करो. U by V बोले तो V du minus U dV by V square करो.
Sir, in the alternate method, you have differentiated the time signal, sir. Y dash t.
Yes,
we got
yes.
two impulses. Sir, it's like differentiation of UV, no, sir. UV dash plus VU dash.
Both methods will produce same answer. No difference. Solve करो. Maybe you have done some mistake. Both methods will produce same answer.
Sir, my doubt is, sir, when we differentiate T rect T by 2, sir, T into
one
differentiation
rectangle
of,
as well as two extra negative impulses.
yes, sir. Here I did not understand, sir, because
what
T
is your
into
problem?
differentiation of, sir, T into differentiation of rect T by 2 plus rect T by 2 into differentiation of T is 1, no, sir.
अरे that is what I said in signals ना. इतने दिन से क्या कर रहे हैं यार? ये discontinuity कैसे मालूम होता है आपको? मैथ से मालूम होता है. Jump locations.
Sir, I tried in the UV form, sir. Then also I got the same answer, sir.
How you will take Fourier transform of T? Over action. You applied UV rule. I will obey. How will take Fourier transform of T?
Sir, I am saying, sir, whether it is correct or not.
No, that is wrong logic. The logic is wrong.
Sir, I applied differentiation for y of t, sir. Means in time domain.
Yeah, you have written. I understood what you are saying. T rect T by 2.
Yes, sir. Then
apply UV rule here.
Yes, sir.
You cannot take Fourier transform of T na. How you will keep it as it is? That is wrong na.
Oh.
Arey,
sir.
My Fourier transform is not defined for neither absolutely integrable nor square integrable signals.
Okay, sir.
So जाओ.
Sir, I have written like, sir, T into del of T.
You have tried well, that is good, but there is no Fourier transform of T.
Sir, but by using product property,
even
T
you
into
use
del
product
T
property
plus 1.
T as it is now, again you have to differentiate rectangle now. That is time waste, unnecessary overaction. One time you will differentiate T.
Yes, sir.
Don't get emotion,
I tried very much, sir. Then I got the answer. Okay, sir. I was thinking like.
Yes, sir.
Sir, good evening, sir.
Yes, ma'am.
Sir, small request, sir. Please go slow, sir.
You are not completed BTech?
No, sir.
Now, which year?
Now I'll go to 4th year, sir.
Okay. I will try, but you practice the problems regularly, ma. I will try. Definitely, I will try. But practice the problems.
Okay. Sir, another doubt, sir.
Ah.
Sir, you said Fourier transform is not defined for T. And in two more terms you said, sir, for square terms in.
That I discussed it as a theoretical statement, ma. Fourier transform is not defined for neither absolutely integrable nor square root. There only see the first slide of Fourier transform. There I have given example. Ramp, growing exponential, or just e power minus 2t. All these signals, there is no Fourier.
Okay, sir.
I have given the first slide of Fourier transform. See it before today's class. You see.
Okay.
Chalo.
Thank you.
Hello, sir.
Sir.
I have a doubt in 12F. Sir, I didn't understand in the case 2, how did you take that?
Third case, input amplitudes are 1, 1, but output amplitudes are 1, 2.
No, sir, not the amplitude distortion, but the phase distortion. How did you take the denominator common, and how did you
not a denominator, frequency common, not denominator, frequency. What we proved, linear phase means theta of omega equals to minus omega t naught. It can form straight line only when the amount of delay is always same. So for y1t, what I have done, 20 I have taken common. That is reduced delay of pi by 200, sir. If I take 60 common, then also I got delay of pi by 200. So frequency can differ, delays are same. So as a t naught is equal, no phase distortion. Okay. Other two cases, suppose if I look at y to t, if I take 20 common, pi by 200. If I take 140 common, pi by 280. They are not equal. Phase distortion occurs.
Okay, sir.
Hello.
Sir, I lost connection. Sir, could you open 18F, sir? Sir, here hidden periodicity, what you told, sir.
Hidden periodicity means, suppose when you are listening to a particular song here,
yes, sir.
Initially they will play some music pattern. Somewhere yes, in the middle of the song also they are trying to repeat it. So after what time it will repeat, we cannot check by our watch. For that we need a tool, Correlogram.
Okay, sir. Okay. Sir, one more thing, sir. So that you gave no Hilbert transform of xt cos omega 0t. Sir, there if it is not given that b is much less than omega 0,
100%
then
they have to give. Otherwise, 100% they have to give, because otherwise the signal itself is a common signal.
Okay, sir. Yes, sir. Yes. Okay. Thank you, sir. Thank you.
Hello, sir.
Yes, sir.
Sir, 26F, can you go?
1 minute. Sir.
Sir, the box thing, can you please explain once again?
Real signals means Rxy2 must be Ryx minus 2. Suppose I have given complex signal like e power j 10 pi t like that.
Okay.
For complex signal extra, you should obey with conjugation.
Okay.
Normally, how we studied even signal, you tell me xt equals to x minus t.
X minus t, yes.
Even
yes.
conjugate means extra conjugate we are placing or not.
Okay. Okay, and the last problem, that mathematical calculation what you have done, that I did not get, like it was low.
Thing is there, xf into h minus f. Hf, h minus f both are equal. Just I multiplied them. A power m into a power n is a power m plus n. This I adjusted like this form such that I will know time domain function. What is the required form? E power minus pi square f square by a is required. But I have 3 by 2. That I have written as pi square f square by 2 by 3. Before exponential, root pi by a is needed, means root pi by 2 by 3. Whatever I have adjusted, I multiplied opposite way. Enjoyment over. This is Fourier transform of Gaussian.
Okay. Thank you.
Is 39.